Hello, hello, Shagath Unknown here. Welcome to another Rust coding stream here on the 9th of November 2022, local time 1646. Let's not waste too much time here, but let's check out the little progress. Well, really nothing's changed, so we just have a quick look at the roguelike here. We got multiple layers, we don't really level up or anything. We never gave ourselves experience. We got traps. I just walked right past one. Let's step on it. What's going on, Tusk? What is going on with you? There we are. We got the stairs, we got rations, we got a hunger meter, we got all kinds of fun stuff going on. So we're gonna bounce out of here. We still got a bug. So the bug is that when we don't, so if I quit the game here, I don't hit load game, I hit begin new game, but it actually still holds the same state as before. So we got a little bit of a bug there. That's part of the tutorial. I fixed it a couple days ago, or a couple sessions ago, but I resynced with the repo, and so some of that progress is some of that bug fixy stuff that I did is no longer in place. It's fine, I just want to call attention to it again, because it's fun. Alright, so there's our little look here. Oh, we got inventory, we got equipment, we got all that fun stuff, right? Eat rations, we're no longer hungry, so we good. All right. Now we're gonna bounce out of there and probably expand that one time. And what we did last time, yeah, I don't do like I don't like to do the starting soon thing on these streams. I just like to kind of get right into these. So where is my browser? Here we are. So what we did last time, which isn't really clear and indicated by the game, is we refactored map building, right? So the behavior of the game did not change at all, but the way that we're building maps did change, and it's now more, not generic is not the word, but it's been abstracted away a little bit. It's a bit of a nicer, cleaner way of doing it so far. So that's going to allow us to implement multiple map generation algorithms. Here we have binary space partitioning, which we're going to try and do one of these today. Cellular automata, drunkard's walk, diffusion limited, aggregation maps, Voronoi hive maps, wave function collapse. So all kinds of different map generation things that we're going to do. It has no it has no title on the app. It definitely does. Like I mean, in the chat we can see the bot put up the correct title and everything. So interesting. It just didn't load on your end. Weird. All right. So we did that refactor last time. So today we're gonna do this test harness, which from my skimming this chapter, there's gonna be a little bit of refactoring here at the beginning. And then, from my understanding, it's going to be a way to basically visualize map generation and kind of let us pick and choose and just test all the map generation stuff. So as we go through and implement all these different algorithms, we'll be able to see them in action and fine-tune things if we need to. Yeah, you were here right away. All right. So let's get started. As we're diving into generating new and interesting maps, it would be helpful to provide a way to see what the algorithms are doing. This chapter will build a test harness to accomplish this, and extend the simple map builder from the previous chapter to support it. This is going to be a relatively large task, and we'll learn some new techniques along the way. Interestingly enough, it's shorter than the last one. Yeah, it's shorter than the last one. It's like half the length. So we're going to clean up map creation. Do not repeat yourself, also known as DRY. I don't think that's actually listed here, but DRY is an acronym. If you are in the software engineering realm, you will see that acronym. It's usually like don't repeat yourself. They do the contraction of do and not. But DRY is the acronym there. You see it all over, and it gets to the point of something I was talking about the other day with the rule of three. That's one of the things. It's a rule of thumb, but the idea is if you have to write the same code twice, you can probably let that slide. If you have to write the same code 3 times, you should probably be refactoring it and you know, making something generic out of it, like a function or whatever. So this is, you know, probably going to be related to that. So in main, we essentially have the same code 3 times. When the program starts, we insert a map into the world. When we change the level or finish the game, we do the same. The last two have different semantics since we're updating the world rather than inserting for the first time, but it's basically a redundant repetition. So we're going to start by changing the first one to insert placeholder values rather than the actual values we intend to use. This way the world has the slots for the data. It just isn't all that useful yet. So here's a version with the old code commented out. So let's take a look at it. Now I'm going to keep trying to do this sidebar thing here. We'll see how it works. There is actually an extension I want to get real quick. I grabbed this one at work. I haven't really been using it yet, but new file. Let's see. File, command. What's it called? Command palette. Was it? New file command. So I don't want to do it from the context menu. I want to do it from the command palette. So if I press Control-Shift-P, this thing pops up, and I want to make a new file from there. For some reason, I'm not seeing it. Okay, we'll just deal with it today. I found it like right away at work. I just like searched and I was like, I wonder if I can find one of these. Oh, maybe this one looks okay. It's through the command palette. Let's install it. We'll give it a try. All right, enough of that distraction. Wait, what are you saying? What are you talking about, Tusk? Okay, so now, distraction over. Let's head down to let player entity. Let's go to the last one here. So this is a round where we insert the stuff into the game for the first time. So there's some code that's been commented out. Let's see how we're handling this. Okay, so there's a few things that are missing. So we insert the marker allocator. Then we insert map new. So I don't see us doing that. So let's do gs.ecs.insert map new 1. So 1 is our depth. And we could see that pop up now. gs.ecs.insert point new. So these are our resources. We need one more, which is the random number generator. So we'll grab that there. RLTK random number generator. So we'll get rid of that one. And we'll probably get rid of a couple of these. So everything until let player entity, but the ordering that they have is a little bit different than what mine is. So I got to look through it. Oh, I didn't remember. I think I do now, Tusk. Been a while. So we're not going to do the builder stuff here. So I'm going to get rid of the builder. And then I'm going to get rid of the build map. Which means we don't really need the position, do we? Yeah, we don't need the position. We do have the player entity. Yeah, I was going to say some of this is going to fail. So we don't have... Wait, why is this not... Oh, my bad. There we are. So player entity, we're going to do 0, 0 as a placeholder thing. Okay. And we're going to get rid of those. We can't spawn entities. So I think everything else is fine. Okay. So we basically removed all the stuff there. If we start the game now, it's not going to work very well. In fact, it might be fun to try. Let's see how badly it breaks. Why are we not at the bottom of the terminal? Feels like we're scrolled up too much for whatever reason. Begin game. Yeah, see? We're in the corner here. It makes sense, though. It makes sense that we would be there. Okay, so now that we've removed some of that other code, again, what we have here are placeholders. So this is a thing that, this is part of the reason I didn't read ahead to confirm, but this is actually a big part of the reason why, oh, baby, come back. You can blame it all on me. Where is my terminal? Let me delete this, or just kill that terminal. If you squish it too far, oh yeah, if you squish it too far, it goes away. Alrighty. So when I did the refactor a few sessions ago, it wasn't a good refactor per se, but I fixed the bug that I showed off earlier. Where if you quit and then start a new game without completely closing down the game, it doesn't actually start a new game. So I had fixed that the other day with a little bit of just a quick and dirty method to do so. But one of the things that I ran across was that we had to make sure we were inserting these resources ahead of time. And otherwise we'd run into a crash as we would try to fetch the resource. So this is why we're putting these placeholder resources in here so that we're able to use them later. Otherwise, if we try to fetch and say get the map, get the point, get whatever, we're going to have a bad time. We're going to crash. That does a panic, so you don't want to get caught doing that. So that should be good there. Let's click back over to the tutorial now. So instead of building the map, we put a placeholder into the world resources. It's obviously not very useful for actually starting the game, so we also need a function to do the actual building and update the resources. Not entirely coincidentally, that function is the same as the other two places from which we currently update the map. In other words, we can roll those into this function too. So in the implementation of state, we're going to add generate world map. So let's take a look at it. Impl state. And I'm going to put it down here after run systems. It does say the implementation of state, so good. Generate world map. And it takes a mutable reference to self and a new depth. So we're going to get the builder. Let mu builder equal map builders. And it's going to be a random builder, but if you recall from last time, it's not actually a random builder yet, because there's only one builder to pick from. But that's going to be changing probably today. So we're going to build map. Interesting. It does take the depth, right? Yeah. I was confused because I remember writing this just 2 days ago. For reference, the tutorial says builder.buildMap, and buildMap is empty. So it's either a typo, maybe they change it later. Maybe buildMap gets changed to not take the depth, which I don't know why that would be the case. Pretty sure we made a big point out of adding that. Let's in fact take a look real quick. Simple map. Build map definitely takes the depth. We're not using it. Oh, wait. Maybe I don't need to worry about it. Actually, maybe I missed a piece of that refactor. Hang on. Let's take a moment. Map builders. Oh, it's mod.rs, yeah. So build map. It's taking the new depth. This thing here, though, when you make the random builder, you take the depth. So I think I can get rid of that. So let's click back over to the tutorial real quick. And let's go to the point where we made that refactor. I'm not seeing a change there, so let's go to the source real quick. Map builder, simple map. Build map, yeah, build map no longer takes that depth. So that's a good catch. It's not a typo, but I don't think that was explicitly called out, and I just kind of went past it without noticing it. Build map has a parameter, and yeah, we need to make that happy wherever it is, because we're not actually using that parameter anymore. So that's on me. Hopefully an astute viewer would have caught that already. Now if I were to run this, hopefully everything would be happy. Okay, build map should just take a reference to itself. Has one parameter. Oh, I didn't save the mod. Okay, yeah. So now we're good. Now we're happy. All right, let's get back to the function I was working on to generate the world map. Oops, I forgot to turn the browser off. My bad. It's okay. Just for the record, all I did was I went in, build map here in the trait, no longer has the depth, and this build map here no longer has the depth. That's all I did. I don't do that often. Sometimes I do. I usually catch up pretty quickly. Okay, so we're good now. So let's get back to this. We're going to build the map. And we're going to let player start. And we're going to open up a scope. And we're going to get the world map resource. All right. And now once we have that resource, we're going to dereference. And then set that equal to the map that we get from our builder. Player start equal builder dot get starting position. I'm usually of the mindset that I don't like this kind of assignment. I don't know why, but I'm typically of the mindset that I'd rather put an equal, get rid of that player start equal, plop a semicolon on the end, and just feed this value back out. To me, it feels better. It feels cleaner. It's just like, say, let variable and then doing nothing with it, not initializing it, and then initializing it in here, when we can very easily do that with the, the construct here of the language. I kind of prefer this way. It's the same code, though. The compiler probably handles both of them the same, I would imagine, because it's not doing anything different. So we're going to spawn bad guys. Builder.spawn entities and mute self.ecs. So that just gets at the world. We not, yeah, it's actually, we actually called it world. Oh, no, the world is the type. Yeah, we called it ECS. Okay, then place the player and update resources. Let player X, player Y equal player start dot X, player start dot Y. Let mute player position self.ecs.write resource. And we're gonna have to get that point, right? Yeah. So we get the point out of the ECS, and then we're going to assign that. Boom. All right, so then we need to update some position stuff. Let mute position components equals self.ecs.write storage. And its position. I feel like it's been a little bit since we've done this because we spent so much time refactoring. Let player entity equals self.ecs.fetch entity. let player position comp equal position components dot get mute player entity. All right. So now what? If let sum player position comp equal player position comp player position comp dot x equal player x player position comp dot y equal player y. Does that work? It's a mutable reference. Yeah, I guess it does. Okay. I was making sure we didn't have to do something like that. I think that's what it is. Whatever. Mark the player's visibility as dirty. Let mute view shed components equal self.ecs.write storage. It's going to be view shed. And then let vs equal view shed components dot get mute star player entity. Cool. And it's going to be the same construct here. If let sum vs equal vs vs.dirty equals true. I don't know why I questioned that up here. I was thinking of something else, I guess. All right, so pretty straightforward. I don't want to spend too much time breaking it down. Basically, we get our map builder, we build the map, we get our player start from it, we spawn things in the map, we get the position resource, the point, and we update that. We get the position components and make sure we add that to the player, set that correctly for the player so they have the new X and Y. And then we set our view shed as dirty so the game knows to recompute our view shed. Simple enough. So now we can get rid of the commented code and simply call our first and simplify our first call quite a bit. So we'll head all the way down here where we're doing that stuff. So we have the simple marker, we have the map, point, RLTK, player entity, insert the player entity, we do the run state, we do the game log, particle system, rex assets, and then gs.generate world map 1. Now that's cool, but we're still not doing it in the new game part, so there's still a bug there. But we're gonna accept it. Oh, hold on. Are we still good? I think, yeah, it looks like we're still good. I just got a Steam thing popped up telling me it couldn't connect to the Friends network. But that happens occasionally, and it's not always bad, but I want to make sure my internet connection hadn't messed up. All right, so we can also go to the various parts of the code that call the same code we just added to generate world map and greatly simplify them by using the new function. We can replace go to next level with FN go to next level. I know we're already here, but okay, we're going to delete stuff, target to delete, all that cool stuff. Then here we're going to say let current depth. We don't even need to do the player start either. We're going to do the world map resource and then current depth. And then it's going to be self.generate world map with current depth +1. Now we already did the spawn in there, so we can get rid of most of this. Yeah. There we are. So, oh, we need the player entity. So we now need to get that here. Cool. And likewise, we can clean up game over cleanup. Wait, it's time to do it. Game over, yeah! Alrighty. I had to. We'll probably delete everything. And then for the builder stuff, let's see. Let player entity. We're not actually getting the builder? No, we don't need it here. Yeah. I don't know why I was thinking. All right, so this is going to be spawn a new player. It's going to be let player entity equals spawner player and mute self.ecs 00. Then let mute player entity writer equals self.ecs.write resource. We get that entity that we have. And lastly, player entity writer is now equal to the player entity that we just got. We can actually delete all of that and literally everything else in here and replace that with this. And there we go. If we cargo run, everything should still work unless I borked something. Give me one moment, actually. Okay, so we begin game and we got a map. If we back out and begin game, we still have the bug, as I already said. Things were not going to fix that, but we die, we're good. If we go to the next level, we're good. Alrighty. So that's exactly what we expect, right? We refactored, and that means the game does not change the way it works, but the code is cleaner. So there we go. Cargo Run gives us the same game we've had for a while, and we've cut out a bunch of code. Refactors that make things smaller. Rock. Indeed. Reused code. And notice, I said the rule of 3. We actually had that in 3 places. So that was kind of the perfect time to be doing that. So making a generator. It's surprisingly difficult to combine 2 paradigms sometimes. So I read a little bit about this last time, and I'm really interested in this. Generators that we're going to be talking about here, they're, as far as I could tell, still not in stable Rust. So we won't be exploring this yet. But I'd like to maybe look at that as a side thing, because I've seen them in Python before. I kind of get the idea of how these things work, but I've never used them. So I think it'd be cool to give them a try sometime. Also, random aside, Rust, Lang, yeet. There's something in Rust called yeet. Are we yeet yet? And is that actually related? Have you ever had an, oh no, it's error related, but there's actually a thing called do yeet that's been introduced to the Rust language, and I just find it amusing. Will we ever be yeet? No, and it's probably for the best. Yeet is a placeholder term to prevent bike shedding and preventing progress on a legitimate and very cool feature. Not a serious language proposal. Whatever. It's amusing. All right. So it's surprisingly difficult to combine 2 paradigms sometimes. The graphical tick nature of RLTK and the underlying GUI environment encourages you to do everything fast in one fell swoop. Actually visualizing progress while you generate a map encourages you to run in lots of phases as a state machine, yielding map results along the way. My first thought was to use coroutines, specifically generators. And let's click at generators and take a quick aside just to look at them. Generators feature gate in Rust allows you to define generator or coroutine literals. A generator is a resumable function that syntactically resembles a closure but compiles to much different semantics in the compiler itself. The primary feature of a generator is that it can be suspended during execution to be resumed at a later date. Generators use the yield keyword to return, and then the caller can resume a generator to resume execution just after the yield keyword. They're an extra unstable feature in the compiler right now. They're added in request for comment 2033. They're mostly intended right now as an information constraint gathering phase. The intent is that experimentation can happen on the nightly compiler before actual stabilization. Further RFC will be required to stabilize generators / coroutines and will likely contain at least a few small tweaks to the overall design. So a syntactical example of a generator, we're assigning it, it really does just look like a closure, except we just yield 1. And then I guess the first time you call it, we get 1, and the second time it returns foo. That's very interesting. Yeah, okay. And I was wondering how that works because it's multiple return types, but just looking here now, there's a generator state, which is yielded and complete. Okay. So that's interesting. And you could do a lot more with that. You could go through and yield multiple values. Okay. It's interesting. We're not gonna go through it any more than we need to, but I guess the idea is that you generate as much of the map as you want to, and then yield, and then do it again, and yield, and do it again, and yield until complete. And that would be a cool thing for this. So generators really are ideal for this type of thing. You can write code in a function that runs synchronously in order and yields values as the computation continues. I even went so far as to get a working implementation, but it required nightly support, unstable, unfinished Rust, and didn't play nicely with WebAssembly, so I scrapped it. There's a lesson here. Sometimes the tooling isn't quite ready for what you really want. Instead, I decided to go with a more traditional route. Maps can take a snapshot while they generate, and that big pile of snapshots can be played frame by frame in the visualizer. This isn't quite as nice as a coroutine, but it works and is stable. Those are desirable traits. To get started, we should make sure that visualizing map generation is entirely optional. When you ship your game to players, you probably don't want to show them the whole map while they get started. But while you are working on map algorithms, it's very valuable. So towards the top of main.rs, we add a constant, show mapgen visualizer. And because this is just literally assigning a constant, a bool to true, I'm just going to go copy paste that into main. You don't have to watch me do it. I'm going to put it right before run state, right after all our mods and everything. All right, and now it's mad because mapgen visualizer is not being used anywhere, but it's fine. Okay. A constant is just that, a variable that cannot change once the program has started. Rust makes read-only constants pretty easy, and the compiler generally optimizes them out completely since the value is known ahead of time. In this case, we're stating that a bool called showMapGenVisualizer is true. The idea is that we can set it to false when we don't want to display our map generation progress. With that in place, it's time to add snapshot support to our map builder interface. In mapbuilders/mod.rs, we extend the interface a bit. Okay, so let's take a look at that. Mod.rs, we have build map, spawn entities, get map, get starting position. Now we have fn get snapshot history. So it's actually just another map. It's a vector of maps. So the snapshot is going to be a complete map. Well, complete. It is going to be a map. We'll decide what means that it's complete. And that's when we'll stop generating. I don't know if that makes sense what I'm trying to say. When I'm saying this is a complete map in here, what I mean is a struct. It's just a struct. It's a normal map struct. We're just storing the whole thing in here. And now we're mad because the simple map builder does not satisfy the trait now, but that's expected. So notice the new entries, get snapshot history and take snapshot. The former will be used to ask the generator. And by the way, if you just spend a moment thinking about it before you can look ahead, what this means is going to get us a vector of maps. It's not on self, however, which is interesting, but I imagine we're going to have to modify the map itself, or the simple map builder, to maintain state of those snapshots. It's going to actually take copies of the map as it goes through the generation. So then that's why I'm a little interested that we are getting vec map. Maybe we're going to clone it or something. I would assume we're just going to hold a vector of maps in the map builder. So we'll see how it goes. So notice the new entries. The former will be, get snapshot history will be used to ask the generator for its history of map frames. The latter tells generators to support taking snapshots and leaves it up to them how they do it. This is a good time to mention one major difference between Rust and C++ and other languages that provide object-oriented programming support. Rust traits do not support adding variables to the trait signature. So you can't include a history vec map within the trait, even if that's exactly what you're using to store the snapshot in all the implementations. I honestly don't know why this is the case, but it's workable, just an odd departure from OOP norms. So you can have an associated type, but I think what they're saying is that you can't do that as part of the trait itself. You can't specify that the associated type has to be a vector of maps. Maybe. Because I think associated types are usually used for generic related things. You have to define an associated type and then you use that later on within the trait. Just like how we do it with the system data when we're doing the systems for the ECS. So you cannot add variables to the trait signature. Yeah, the trait signature. Okay. I think I'm fine with that though. I don't know. I think I'm fine with it because a trait is like a contract that you're saying you're going to uphold. And I don't know if I want that contract telling me what kind of data. I mean, there's some degree where it says what kind of data I have to give back, but I don't know how much I want that contract controlling the struct itself that is implementing the trait. Right? This should just kind of define behavior. This should not be defining data. That's how I view it. This defines behavior. So I think that's why it's done this way. I mean, it kind of bothers me because I see this and I think, oh, what's going on? Maybe I should address this because they're saying it like it's such a weird thing. I guess I'm trying to figure out where this happens in C++. That's what's throwing me off because this is not an object-oriented language, really. It has something similar to it, but it's not the same. These are not classes and everything. So a class is a struct with some attached behavior and the ability to make some things public and private in, generally speaking. A class is also just kind of a fancy way to say a namespace as well. It's a namespace with some data, some of which is public and some of which is private, as well as some attached functions, some attached behavior. Rust, you don't get to make that, what you get to do is you get to make the data and then separately attach behavior to the data. It's that idea of composition. So I think that's perfectly fine. But what I'm trying to figure out is I don't really understand the difference. We're saying there's a, well, no, I understand there is a difference. But what I mean is I don't know where C++ does what they're describing here. The C++ equivalent is like a class, right? So we add variables in a class, which is the same as adding variables to a struct here. That to me seems pretty one-to-one. The difference is how the behavior is attached, right? Where the behavior in C++ is part of the class itself, and in Rust it's part of an impl block or a trait. I don't know. I don't want to go down this rabbit hole anymore. I feel like I'm reading too much into it. I just don't know what they expect other than what we have, basically. Unless they want straight up classes and everything. Okay, so inside simple map, we need to implement these methods for simple map builder. So we'll add supporting variables to our struct, which is going to be that history, which is exactly what I claimed it was going to be, a vector of maps. And I don't think we need anything else, so that's good. Notice we've added the history vec map to the structure. It's what it says on the tin, a vector of map structures. The idea is that we'll keep adding copies of the map into it for each frame of map generation. So then we'll go to the trait implementations after that. So in simple map, we'll say history vec map. I think the idea though is, just going back on that point, I think the idea is to say, if you're a map builder, you also have this thing. And then it's going to be mad because it's like, I don't know how to do this. Yeah, I don't know even how to make it recognize what I'm trying to do. But I think that's what they want, and then it would it's like what they want is for that data to be attached to the trait, not the struct. Which I don't know, I don't like the sound of that. So then like in here, in this impl map builder for simple map builder, you would then define history vec, you would define it down here, and it wouldn't be a part of the actual struct. So that has pros and cons. One of the pros would be that it does take some of the data out of the struct if it's not absolutely essential for the behavior of the struct and it's more associated just with a trait. But again, I also feel like that would, I don't know. I like the whole composition thing. I kind of like the struct owning all the relevant data. So I'm not going to keep thinking about that. That'll keep me going for another hour. So implement some missing things. And this one is exactly what I thought it was going to be earlier, self.history.clone. And the reason I centered in on that earlier to get the snapshot history, I noticed we were returning a map. It's not a reference to anything. It's a vec of map. And I was thinking, I think I even said earlier, are we going to clone this? What's going to happen? Well, that's it. We just clone the history that we're maintaining. So then for snapshot, if show mapgen visualizer, let's just have it pull it in like that. Let mute snapshot equals self.map.clone for v in snapshot revealed tiles iter mute. Everything is now revealed. Self.history.push snapshot. Yeah, so if we're supposed to do this, then we clone the map, we make everything visible, and we put it in the vec. That's actually, yeah, really easy. So, very simple. We return a copy of the history vector to the caller, and then we first check to see if we're using the snapshot feature. No point in wasting memory if we aren't. If we are, we take a copy of the current map, iterate every revealed tile cell, and set it to true, so the map renderer will display everything, including inaccessible walls. And we add it to the history list. Now, we can now call self.takeSnapshot at any point during map generation, and it gets added as a frame to the map generator. In simple map.rs, we add a couple calls after we add rooms or corridors. So let's take a look at it. If okay, apply rooms to map. So we're going to do it here, self.takeSnapshot. So we don't, I kind of like that because we don't check here. We only check in one place. Do we need to actually do that or not? So it's a nice way to just have the code. It's like try to take the snapshot. I kind of like that. So then we do it after push rooms. Is there not another one? I don't see another one. I was thinking we might do it for every tunnel like this. I might take a look at that and see how it looks myself, because it'll be cool. But we got some work to do to get to that point. We need to render the visualizer. So visualizing map development is another game state. So we go to our run state enumerations, and it's the last one, map generation. And now the code's going to be a little bit mad. So visualization actually requires a few variables, but I ran into a problem. One of the variables really should be the next state to which we transition after visualizing. We might be building a new map from one of three sources: new game, game over, or next level, and they all have different states following the generation. Unfortunately, you can't put a second run state into the first one. Rust gives you cycle errors and it won't compile. Okay, I was actually about to say, no, you kind of can though. You can use a box run state, but that doesn't work with run state deriving from copy. Oh, interesting. I fought this for a while and settled on adding to state instead. Interesting. Where is state? Okay, oh, we got a lot of stuff here. Map gen, oh, whoops, sorry. Map gen underscore, we're gonna need this a few times. Next, state, and it's an option, run state, map gen history, vec map, map gen index, usize, and map gen timer, F32. Okay. So the tutorial says we've added mapgen next state, which is where the game should go next, mapgen history, a copy of the map history frames to play, mapgen index, how far through the history we are during playback, and mapgen timer, used for frame timing during playback. Since we modified state, we also had to modify our creation of the state object. Right, so if I save, we're gonna get some issues now. Down here, yeah. So let's have this help me out a little bit. And what are we gonna do here? So next state is going to be, oh, we're actually starting it with some. Run state main menu. Menu selection, yeah, that's a lot. Menu selection, GUI, main menu selection, new game. Okay, next, what's it gonna be? Of course they come in different orders. I use the autocomplete, or I do the autofill to have it brought in automatically for me, and often I get different orders than they get. So I don't know if they manually do it or what. All right, timer 0.0 for now. Find it interesting we're actually putting a state in here. Well, maybe not. Because we're going to show the first map generation of the game. Okay, that makes sense. So we've made the next state the same as the starting state we've been using. So the game will render map creation and then go to the menu. We can change our initial state to map generation. Yeah, where's it at? Where are we inserting the run state? Here it is. So instead of all that now, it's going to be map generation. And then we need to implement the renderer. So in our tick function, we need to add the following state. Where is the tick function? Here we go. Match new run state, and we're going to start with map generation. Map generation. If not, show map. Okay, hang on. Why are you mad? Is it that? Oh, whoops, I forgot my arrow. That's why. If not, show mapgen visualizer, then new run state equals self.mapgen next state.unwrap. Don't like that, but okay, sure. Then ctx.clear screen. So if we are supposed to show it, we clear the screen, then we draw map and self.mapgen history, self.mapgen index. I'll use the context there. So we're going to have to increment the index. Wait. We'll, yeah, we're going to have to make a change. Okay. I was like, this isn't working because we need the ECS. And this is not the ECS. Okay. So we'll deal with it in a moment. Then self.mapgen timer plus equals ctx.frame time milliseconds. If self.mapgen timer is greater than 300, self.mapgen timer equals 0.0, self.mapgen index plus equal 1. If self.mapgen, we're going to have to break down what's happening here. All right, so we draw the map. The timer. Oh, we do set it equal to 0. Okay, yeah. So the timer builds up, actually. We take how long the frame took, the frame time, we add it to the timer. If the timer's over 300 milliseconds, then we set it back to 0 and we go to the next thing in the map gen. And then we make sure that the map gen index, so when I say next thing in the map gen, that's what I mean. We increment the index. And if the index is greater or equal to the length of, like, to how many maps we have, then we're done. And we go to the next run state, which is the one that gets us, like, into the game or whatever. Okay. So the tutorial says this is relatively straightforward. If the visualizer isn't enabled, transition to the next state immediately. Then we clear the screen, we draw a map, and then we do what I just described. Add the frame duration to the mapgen timer. If it's greater than 300 milliseconds, set it back to 0. Increment the counter. If the frame counter has reached the end of our... I don't think it means frame counter. But if we reach the end of our map history of our snapshots, transition to the next game state. The eagle-eyed reader will have noticed the subtle change here. Draw map didn't used to take a map. It would pull it from the ECS. In map.rs, the beginning of draw map now changes to taking in a map. So our regular, so all our draw map stuff might get a little angry for a minute. So let's take care of that. How do I get to it? I go in here, I delete that and I say map.rs. And I look for FN draw map. And instead of that, it's now a map. We're probably going to change that name to map. And then we probably just get rid of that. And everything else should work. Magic. All right. Wasn't really... Yeah, I mean, there wasn't a lot to do there. So our regular call to draw map in tick also changes. Where is it? Mad right here. Yeah, self.ecs.fetch. Whoops. Map. La mappa. Okay. Tiny change. It allowed us to render whatever map we actually need. Lastly, we need to actually give the visualizer some data to render. We adjust generate world map to reset the various map gen variables, clear the history, and retrieve the snapshot history once it has run. So this is part of why we did the refactor earlier in prep. Okay, so the first thing we're gonna do is, wait a minute. Okay, that's not the entire function, that's why. I was like, what? Self.mapgen index equals 0. Self.map and timer equals 0.0. Self.mapgen history dot clear, not clean, clear. Let me builder builder.map, let player start. After builder.map, self.mapgen history equal builder dot get get snapshot history. Let me world map resource. That's cool. Builder get map and the player start. Everything looks good. Okay. If we cargo run now, we get to watch the simple map generator build the level before we start. Well, let's try it. This is cool. I'm excited. Whoa. Hold on. Did you see that? Those were... Oh, no, I'm blocking it. I kind of am. It was pulling in trunk commands and stuff from another project I've been working on. It's like trunk serve and all that. Get push, different things that are not what I've been doing here. Ah, there we go. Yes. Oh, that's why we didn't do it for every tunnel, of course. Because we didn't need to. Begin new game. And then if I go get myself offed, if I can find a manster. We get to watch it one more time. I kind of want to do that. That's cool. New game. Or not? Are we only doing it? Oh, yeah, we have a problem. We're only setting that state one time. So, of course, we're not going to watch it more than once. Duh. Okay, we're good then. For now. So, that's that. Wrap up. This finishes building the test harness. You can watch maps spawn, which should make generating maps, the topic of the next few chapters, a lot more intuitive. Yeah, so I think it'd be cool to do the map generation snapshot stuff everywhere. Or not snapshot, but anytime we have to generate a new map, I think we should do that. The tutorial does not have us doing it. I might add that on my own later, because I think it'd be cool. But yeah, so far so good. I think that's awesome to be able to watch that happen. And yeah, as they say, it's going to be really cool. I've seen, just clicking through some of these sections, I've seen where it's going to go. And it's going to be really cool to see this happening in not real time, but like in front of us in phases. So What I'm really excited for now, we're going to do one more section today. That took just exactly an hour right there. So we're an hour in, and this is a bit of a beefier section here. As if we look at our scroll bar, binary space partitioning room dungeons. That's about the same. Okay. Interior design is actually a little bit shorter even. We might try to do both, but definitely going to do at least this one today. BSP room dungeons. Alright, so a popular method of map generation uses binary space partition to subdivide your map into rectangles of varying size, and then link the resulting rooms together into corridors. You can go a long way with this method. NetHack uses it extensively. Dungeon Crawl Stone Soup uses it sometimes, and my project, One Night in the Dungeon, uses it for sewer levels. This chapter will use the visualizer from the previous chapter to walk you through using this technique. Also, pretty sure Doom uses it. BSP Doom makes use of a system known as binary space partitioning. And I believe, the second one confirms it. I believe they used it to call things and figure out what they need to render and what they don't need to render as a way to basically save on computation. And I think that's what we were seeing on that little tree structure there, on that little graph. But it's gone now. Yeah, so basically, if I remember correctly, the way Doom uses it is you kind of build out this tree, and then you're able to prune branches of the tree that you can't see and very quickly figure out what needs to be drawn and what doesn't need to be drawn. There's a lot of issues in figuring out, like, we could just like draw everything, but we have to make sure we draw the closest things last because we're like painting over it. You get things, you run into an issue called like Z fighting, where things that should be behind something else are trying to show up in front of you. You run into issues like that. So this was a quick way, rather than trying to like sort out everything. This, tree structure helps keep everything sorted for us, and we can easily prune off branches. That's the way I understand how they use it in Doom. You're able to quickly prune off things that you can't see and like only draw what's actually being seen. So we can see here, it looks like this is kind of showing how a map might be using it a little bit, but I don't know. I think I do want to make a, when I start learning WGPU, I'm probably going to do a Doom Engine port using WGPU, because I've never made a Doom Engine port, but I've always wanted to. So that'll be a good chance to really get used to it. All right, and everyone's done a Doom Engine port, right? So anyway, just wanted to call attention to that Doom back in the 90s was making use of this. Like, this algorithm is not just some like random goofy thing, right? I mean, NetHack is pretty old school, and it uses it. So I mean, that says quite a bit. So this chapter will use the visualizer from the previous chapter to walk you through using the binary space partitioning technique. So we're going to implement a new map, subdivided BSP. So here's the boilerplate. So we're going to make a new file in map builders called BSP dungeon, and we're going to make the basic struct. So let's go ahead and do that. Now, let's see. I'm going to try to do this from the command palette. I want to say create new file, but where's it going to go? Map source / map builders / BSP dungeon.rs. I don't know if that worked. Something popped up. Okay, hang on. Let's pop in here. That's not what I want. How do I get it to do that? No. Yeah, I can't just have it make that. There's got to be a better way to do it. All right, BSP dungeon.rs. Yeah, okay. Let's make it here for now. I want to get that down on the command line, or not the command line, but the command palette as a quick way to make a file in a certain directory. Control Alt Windows N, yeah, that's fine, but I want to make file utils. That's Visual Studio Code. Okay, file utils might be the one I actually want. New file. That's file, new file. Maybe. Ah, it is. But why did I put it in map builders? That's my only concern. What if I wanted it to go in source? Can I make that happen? New file. Test.rs. And then what if I say file move? Is that worth doing all of it on the command line, or not in the command palette? I don't know. Maybe I can get really used to it and you can get like snappy with it. That could be cool. I would like to be able to keep that stuff off the screen a little bit and make more use of the screen. I think it works good for these kind of videos and stuff. Okay, sorry for the little distraction there. So first thing I'm going to do is go into... We don't have simple map in here, do we? Yeah, no, we don't have it in here, so we just pull it into mod. And we're going to say mod BSP dungeon. That way, this thing will give us proper syntax highlighting. So pub struct BSP dungeon builder. It's going to have a map, starting position, depth, I32, rooms, back rect, and history, and rects. Okay. So, the tutorial says this is basically the same as the one from Simple Map Builder, and we've kept the rooms vector because this method uses a concept of rooms as well. We've added a rect vector. The algorithm uses this a lot, so it's helpful to make it available throughout the implementation. We'll see why it's needed shortly. Now implement the map builder trait to the type. So let's go ahead and... Also, yeah, this is going to get mad here, so let's pull a few things in. We're going to import map, do create map. That should satisfy it. Position and rect. Perfect. Okay, now we're going to import map builder for BSP dungeon builder and implement missing members. So there we go. We have everything now. So get map is super easy. So let's start with it. Self.map.clone. Get snapshot history should be just as easy. Self.history.clone. What else do we need? Starting position. Self.startingposition.clone. Okay, so far so good. Take snapshot is probably about the same as the other one. If we go to simple maps, or simple map, excuse me, and we grab this, plop it in here, that should be the same, right? I have to bring this thing in. So let me double check if show mapgen visualizer, let mute snapshot, yep. For V and snapshot revealed tiles, yeah, that's all the same. Okay, as I expected it would be. So spawning entities, we're gonna do the same as before. So we could do that one pretty quickly. For room in self.rooms.iter.skip one spawner spawn room. ECS room self.depth. Now I was going to say spawner is going to be mad. I already knew that was going to happen. I could tell by the way it didn't autocomplete, but I was like, well, it's not really a lot to type or anything. So now the big one is going to be build map. That's really the main thing that's changing on us, right? So we should do something here, right? So this is going to be a new algorithm, brand new way to build the map. So let's see how we're going to do this. This is also pretty much the same as simple map builder, but build map has a comment reminding us to write some code. If you ran the generator right now, you'd get a solid blob of walls and no content whatsoever. Well, kind of. We didn't actually call this, we're not using this in mod.rs. We didn't add this to the random map generator thing. But anyway, you'd have a solid blob of walls and no content whatsoever. We also need to implement a constructor for BSP map builder. So once again, it's basically the same as simple map builder. Let's pop in here and do it real quick. Impl BSP dungeon builder FN public function new depth I32, and it returns a BSP dungeon builder. And then so it's going to build a BSP dungeon builder with map new depth. Ah, crap. I broke the so when you first have it autocomplete that, you can tab between all of them really nicely, and I broke it. Position, like this right here. So I can type 0 and then tab, and it brings me to Y. That's the functionality I like right there. But I lost it. I broke it. Depth is new depth. Rooms is just going to be an empty vec. Is there any benefit to doing vec new over something like this, like the vec macro? I'm actually not sure, because an empty vec macro should just do vec new and not put anything in it. And I've seen, I don't know, I think I've done that a few times in some code. I don't know if there's a benefit to either one. Okay, so there we have it. And then we're gonna go to, we're gonna go to mod.rs and change the random builder function to always return our new map type. So I'm gonna comment that out. That's not how they do it, but I'm going to comment that out just to keep it there for later. We're going to do BSP Dungeon Builder new. So once again, it's not the slightest bit random, but it's far easier to develop a feature that always runs rather than trying until it picks the one we want to debug. Okay, so now we're going to building the map creator. We're going to build it. Okay. We'll worry about swapping out map types later. On to making the map. Note that this implementation is ported from my C++ game, One Night in the Dungeon. We'll start with rune generation. Inside our Impl BSP map builder, we add a new function. Impl. I love saying that. BSP dungeon.rs and fn build and mute self. So that makes sense. And what are we going to do? Let mute RNG equal random number generator new self.rect.clear self.rect.push rect new to self.map.width -5 self.map.height -5. We're going to have to break down what's going on here. Start with, and I gotta scroll over to read this. Start with a single map-sized rectangle. Why are the 5s though? What am I missing? It seems like it's a little bit smaller than the whole map. We start it at 2, 2, so we bypass like the first walls and stuff, right? And then if I can type width, I don't see why 5. That's the only thing I'm missing there, I guess. Seems like you're going to go almost to the end, but not quite. Whatever. Not a big deal right now. Let's understand the algorithm. Let's get it implemented, and then we'll worry about the specifics. Okay, I assume it's going to look fine. They know what they're doing. Let first room equal self.rect. No, I'm not saying don't try to understand the algorithm. I'm saying if there's a reason for it, let's see the whole algorithm before we get caught on like Y5 instead of mapped out with -1 or 2 or something. Like I can understand -1 because you're getting 1 away from the border, or even -2. So again, though, I'm not saying not to think about the algorithm, just let's not get caught up in it before we've seen the whole thing. Self.add subrects first room. Well, that tells us we're going to need a function. Divide the first room. Okay, so we literally just get the first thing in rects, which is what we just added. We just pushed it in, and then we're going to get it, and we're going to subdivide it. We're going to divide the first room, which makes sense because just from the little bit that I know about binary space partition, this does make sense. Up to, I'm copying these comments. I don't recommend copying code, but I'll copy and read the comment. Up to 240 times we get a random rectangle and divide it. If it's possible to squeeze a room in there, we place it and add it to the room's list. Okay, so let mute n rooms equals 0. While n rooms is less than 240, let rect equals self dot get random rect and mute RNG. So we're gonna need another function here because that one doesn't exist. Oh, oops, I called it rn. All right. So in rooms is what we're calling that, but it's really not the number of rooms. We're not going to actually have 240 rooms. We're going to do 240 attempts. So it's almost better to call it like I or something. I mean, just from what I can see so far, and the comment, up to 240 times we get a random rectangle and divide it. If it's possible to put a room, we do it. I don't think we're actually putting 240 rooms. So let rect equals self.get random rect. Let candidate, that seems wrong, but it's right. Self.get random sub rect and mute RNG. If self.is possible candidate, apply room to map and mute self.map and candidate. So you know what's cool now? Yeah, if you were paying attention, when I put candidate there, this filled in rect because now it knows that that has to be a rect. So there's going to be cool things here, like if I have it make get random subrect, if I click on it and say generate, it knows that it has to be part of BSP Dungeon Builder because it's called on self. It knows that it has to take a reference to itself, like and mute self or just and self, depending on how it's being used. I think, well, we'll see. I don't know if it's going to need to be mutable. I haven't thought that much about it yet. But it also knows that it needs to return rect. So it can generate a nice like function signature and everything already just by how it's being used. I love that. It's not the only language that can do that. Lots of tools can do that. You can do that with IntelliJ and stuff with Java. But it's just always nice to see like everything fall into place like that. Apply room to map, self.rooms.push, candidate, self.add subrects rect. Now that tells us a lot about add subrects as well. I guess we already knew it had to take a rect anyway. But what we don't know yet, we as humans, as programmers, we might be able to imagine how this is going to work. We're dividing a room, but we're not returning anything. So that means it's probably going to be an and mute reference to self, just like this build is here. That's going to be my guess. We'll see if that's actually the case. Maybe I'm missing something. Self.take snapshot. And then after that, we do in rooms plus equal 1. And then after this, let start equal self.rooms 0.center self.starting position equal position x start.0 y start.1, and boom, there is our algorithm. But there's a lot of extra stuff going on here that's not implemented yet. But the tutorial wants to take a little break and explain it. So let's take a moment to actually read this ourselves before I look at the tutorial. Let's try to understand what's going on, and then we'll read the tutorial explanation. We get 2 explanations. We get the one that I do encourage you, as a programmer, to try to understand what's going on your own as much as you can. So self.rect's clear. I think that's self-explanatory. Get rid of anything that's there, right? And we start by making a big old rectangle that's like basically the size of the map. Maybe I'm missing something, but I'm still a little bit confused by the -5s on it. I don't know, is there something inherent with the 5 that I'm missing on the edge of the map? I don't know. 2 and 2, we're kind of going in a little bit from the corner. And then that -5 and -5 brings us in from the other corner. It's just, we're doing different amounts on each corner, and that's what I don't quite understand. But after that, actually, I wonder, is that code at all similar to anything we've done over here when we're figuring out positions for rooms or whatever? I don't see 5s anywhere. Okay, whatever. So we just make a big old rectangle over the whole map, and we call that the first room. But we're not actually like pushing it in as a room yet. We just name it first room. And then we divide it. So however this is going to work, we're dividing it. Let's just pretend it divides it down the middle or something. And then we do this loop. So this add subrects, I guess it's going to go into rects here. Yeah, I'm not quite sure. We're going to have to see exactly how that works. But we do this add subrects, and then up to 240 times, we just get random rectangles and divide it. And if you can put a room in there, we do it. So let rect, we get a random one. And then we subdivide that. Yeah, we subdivide that random one and call it a candidate. And then we check to see if it's possible to put a room there. And if it is, then we actually put the room there. And that's our snapshot, because we've built the, we've added something to the map. So that's our snapshot. Now what I'm curious about is how this factors in the tunnels, because that's really it. Once we're done with that, we get the starting position and set it, but that's really it. So it's very, very straightforward. But I don't know about tunnels. Linking up the rooms, we might have to add something else, or that's getting factored in with the way the rectangles were. I don't think it would. Yeah, so we'll see what it does. So let's get over here and read about it from the tutorial a little bit. Oops, my bad. All right, so what on earth does this do? Well, we clear the rect structure as we created as part of the builder. It'll be used to store rectangles derived from the overall map. We create the first room, which is really the whole map. We've trimmed a bit to add some padding to the sides of the map. Yeah, but they're different amounts of padding. It breaks my brain. I don't like it. It's probably fine. We call add subrects, passing it the rectangle list in the first room. We'll implement that in a minute, but what it does is it divides the rectangle into 4 quadrants and adds each of the quadrants to the rectangle list. Okay, so now we set up a room counter so we don't infinitely loop. And while the counter is less than 240, a relatively arbitrary limit that gives fun results. 1, we call getRandomRect to retrieve a random rectangle from the rectangles list. 2, we call getRandomSubRect. Using this rectangle as an outer boundary, it creates a random room from 3 to 10 tiles in size on each axis, somewhere within the parent rectangle. And then 3, we ask is possible. If the candidate can be drawn to the map, then every tile must be within the map boundaries and not already a room. If it is possible, we mark it on the map. We add it to the rooms list, and we call add subrects to divide the rectangle we just used, not the candidate, to subdivide the rectangle. Okay. There's quite a few support functions in play here, so let's go through them. Alrighty, let's take a look at it. So what are we doing first? Add subrects. Well, I'm going to let this generate it for me, and we'll see what changes. So this does need to be a mutable reference, which we already inferred that earlier. I made that comment before, but it got us a long way there, and we're not actually returning anything. So, and to be fair, I had no way to know that, because just because you're not using a return doesn't mean a function doesn't return something. You just might not be using it. So everything else here is fine. Actually, we're going to rename it from first room to rect. It had no way to know that because the way we're using it here is with something called first room. Maybe if I had done it here with rect, it would have called it rect, but that's fine. Still did most of the work for me. Let width equal I32 abs. So we're getting the absolute value rect x1 minus rect x2. That way it doesn't matter which one is larger than the other. Let height equal I32 abs rect minus y1 minus rect y2. Yeah, so rect dot y1 minus rect dot y2. I said some strange stuff there when I was typing. Let half width equal I32 max width over 2 or 1. Yeah, because that could give us 0, I guess. Okay. And then we're going to do the same with half height. So half height, and it's going to be exactly the same thing, but with height. 2 and 1. Yeah, okay. Now, self.rect. Okay, can I do something goofy? Come on. Come on. Why do you keep changing things? Oh my god. I'm being lazy and it's not working. Self.rect.push rect new rect.x1, and then it changes. So this is actually identical for all of them. So that's cool. We could start from there. Rect.y1 half width half height. Okay, x1 and then rect.y1 plus half height, half width, half height. This is one, I'm going to type all these out, and I might actually copy in theirs after I do it just to confirm that I didn't make a mistake. We'll try to reason out what's happening here as well. So we're going to get x1 plus half width, and then y1, and then half width, half height. All of them are going to use the half width and height. So then this is going to be half width, and then rect dot y1 plus half height, half width, half height. Okay. That one got away with being just short enough, and that slightly bothers me. Okay. So let's try to reason what is happening here. It's not too bad. I think I get it, but we got to like take a moment to understand it. So we get the width and height of the rectangle. That's easy enough. And we get the half width and half height. That's easy enough as well. We're dividing the room. We're doing it into fours, right? Into quadrants. We already determined that. So if we take x1 and y1, that's the upper left of the rectangle, and then we did half the width and height, that gets us the upper left quadrant, right? Because we're saying, okay, here's the whole thing. Well, go to the corner and only get me half of it. So that's the upper left. That one's really easy. Then the next is we're taking the same X quadrant, but we're moving down by half the height of everything. And then we're getting that same like half height, half width and half height. So that's the bottom left quadrant. And we basically repeat the same by moving X over and getting both Y variants as well. So we're getting, here we move X over and get Y1. So that's the upper right quadrant. And here we move X over and Y down to get the bottom right quadrant. So we've basically, and notice the width and height of every rectangle that we're doing is half width and half height of the entire rectangle we started with. It's essentially dividing it into quadrants right down the middle. So simple enough. I am, again, for safety, just to make sure I didn't flip a sign like a doofus or something, we're going to just plop that in there. And it probably didn't change anything, but just for safety, because I reasoned my way through it. I hope it makes sense what we're doing, but I could have flipped a sign somewhere or like just mistyped a sign somewhere. I'd rather not have it failing. So there we go. So the function add subrects is core to the binary space partition approach. It takes a rectangle and divides the width and height in half, and then creates 4 new rectangles, one for each quadrant of the original. These are added to the rects list graphically, so these little boxes demonstrate what it's like. So we have this 0 rectangle on the left, and then we have 1, 2, 3, and 4. Although the order that it looks to me like they're appearing is actually 1, 3, 2, and 4. Just because X remains fixed, but Y goes to Y1 plus half height. So we do this one first, then we move Y down, then we move X over with rect.Y1, then we move X over with rect.Y1 plus half. So I don't know if I'm helping or not, but it looks like that's the order we go in: 1, 3, 2, and 4, just based on how these are numbered at least, and how the code is written. You could change it. You could put whatever. It doesn't matter. The order doesn't matter in this case. It might matter for how I don't know if it would or not. I don't know if it would matter in self.rect, what order they're in. We'd have to take another look back at how self.rect is being used. I know you can't see VS Code yet, but trying to confirm real quick. Self.rect. No, not really. Wouldn't be a big deal at all, I don't think. Well, no, because we don't know where. Yeah, other things are using it, so we'd find out. Okay. So next we're going to do get random rect. And that one's a lot shorter. That one's pretty easy. So I was going to say, let's figure out what it does. No, just read the name. We know what it does. We know it's going to have to return a rect as well. So why is it mute? And mute self, RNG, and mute random number generator. I can understand why the random number generator needs to be mutable. And it returns a rect, so we're all good there. So if self.rects.len equal 1, return self.rects 0. And then otherwise we do let idx equal rng.roll dice 1 and self.rects.len as i32 minus 1 as use size. Now the reason we have to do that minus 1 is because we're using it to index in self.rects idx. We're indexing in, so we start at 0, right? Simple enough. I don't know if this is worth even explaining. If there's only one thing in, we get the one thing. Otherwise, we roll and use that value we rolled to get the rectangle. It's not very special. All right. So it's a simple function. If there's only one rectangle, yeah, I literally just described it. Otherwise, it rolls a dice of 1D size of rects list and returns the rectangle found at the random index. Next up is get random subrect. It's a little beefier. So I think for that, we need subrects, kind of like that. And then, yeah, okay. We'll see how it goes. So, generate it. It returns a rect, that's good. RNG, rect, all that is good. So I don't need to change anything. I still don't know why self is a mutable reference there. Self does not contain the random number generator, and you wouldn't be passing them separately if it did. All right, whatever. Take their word for it. Let mute result equal rect. So we're just setting up a rect from the beginning. Let rect width. I cannot type that word when I'm talking. That word's done that to me like every time. Yes, we get the width and height, which is similar enough. We've done stuff like that already. Also, just to keep it happy, we're gonna put result here at the end just to make sure it sees that and it's like, oh, you're returning a rect. Cool. All right. We're actually setting it to the one that we started with. Because we're going to subdivide it. Yeah, okay. Let W equal I32 max 3 RNG dot roll dice. Was it 1 I32 min rect width 10 minus 1 plus 1. We're gonna do the same for height, basically. Not much is gonna be different. RNG roll dice 1. So this is interesting. We're doing a max between 3 or a random number between this I32 min. Oh, no, not. Okay, not I32 min, but I32 min. I32 min. This min here is the value, the smallest value that can be represented by an I32. The min we're using is the function min. So whatever's smaller between the width or this value 10. So we roll between that stuff. We're just basic. Okay, I see what's going on. Result. Let's break it down in a minute when I get done doing this. It's clever. Okay. So that's it. Basically, we get the width and height. None of that's special, right? But what is the roll here? So max is between 3 and okay, so when we say I32 max, we're saying we have two numbers. We have 3 and some random number. So the random number can be a 1 or a 2, and if it is, we actually pick 3. I think the reasoning for that is because you can't really have a room that's smaller than that. A room of 2 kind of works, but not really. So yeah, you have a hard time getting a room smaller than that. I think that's why we picked 3 here. So then we're either going to have 3 or whatever number we get from here. And this number can be 1 up to whichever one of these is smaller. So the width of the rectangle to 10. So if the rectangle is 5 and this is 10, we pick 5. If the width of the rectangle is 27, then we pick 10. So we roll between 1 and 10 or 1 and 5, whatever. 1 and some value from here. We take away, we actually subtract 1 from that as well. And then we add 1 to it. So what is the 1 being added to? Oh, the 1 is being added on at the very end. Okay. I'm not 100% sure why some of that is happening. It's going to depend on how they're being used down here, I guess. So let's see. I might want to just write a comment in and work one of these out real quick. So we're going to say rect width equals 6. We're going to say, so max of 3 or, and then this is where we go into this thing, rand of 1 to min of 6 and 10. So we're gonna pick 6 in this case. We're gonna roll, then we're gonna take 1 away from it. So max of 3 or something between 1 and 6. Minus 1. So if it hits 4, we end up with 3. Which then they're both the same, so we get 3. If we hit 5, then let's say we pick 5. Then we add another 1 to it, we get 6. So I mean, yeah, I don't know. It's not. I don't know why we subtract 1 here. I don't know why we're adding 1 here. I don't know if there's any big magic going on with that or not. Hopefully it'll be broken down if there's a specific reason for it. I'm not seeing anything like special. What I do know is that we want to get the sub rect. Let's try to think of it in context of that. So the result rectangle x1 is a random number between 1 and 6 minus 1. So we started at 0. Yeah, it could be 0 to 5. Oh. I see. I see what... Okay. 0 to 5. There's a trick here. The number here being 10, I think there's a link here. Because this can be at most 5. And this here goes a minimum of... Oh, no, a maximum of 10. By putting that there, if this gets above 10, then we pick 10. So a maximum of 10, then the most this can go over is 5. So what we have to think about is we have a full rectangle, right? And then we can go over 5. Okay. I don't feel like I'm making it any more clear for either myself or you. I mean, I see what's happening on these lines, though. We're shifting where the rectangle starts. That's what we're doing. We're shifting x1 and y1. And then for x2 and y2, we add the width, which we calculated here. So one thing that does is we have differently sized rooms. They're not all just squares. Like, they're not all evenly. You might have more rectangular rooms, skinnier rooms, fatter rooms, or whatever, because you generate different values for the width and height here. So that's cool. I don't know if I want to like try to break anything else down here. It's a little odd. I think I get it, but it's very hard to explain, and I think working with it more will help. So let's see how they describe things. This takes a rectangle as a parameter and makes a mutable copy to use as the result. It calculates the width and height of the rectangle and then produces a random width and height inside that rectangle, but no less than 3 tiles in size and no more than 10 on each dimension. You can tweak those numbers to change your desired room size. It then shunts the rectangle a bit to provide some random placement. Otherwise, it would always be against the sides of the sub-rectangle. Finally, it returns the result. That's okay. So that makes a lot more sense, and that's kind of what I was seeing when this result x1 plus equal and result y1 plus equal. I was like, we can move over at most 5, and there seems to be some relation to this value of 10 here. It's half of the max room size, so that kind of makes sense. Okay, and we're literally just moving it to make it a little bit more random. There's no other, like, there's no necessary reason for this. But what we're saying is, if we didn't do that, it would always start in this upper left corner here on 0. But by doing that, it might start like closer to here, like closer to the center point, and be positioned like around here or something, right? So, okay, that's all cool. It all makes sense, I think. But yeah, so this is it. The random width and height, no less than 3 and no more than 10. That's all. And it says you could tweak the numbers some. So there's nothing inherent to the algorithm or anything, right? This is just what looks right for the game. That's probably the key here, is what looks right for the game. You can tweak it, you can get some different results. This is just how he has defined them. That's all. So finally, we're going to do the is possible function. I know I spent a lot of time looking at that, but again, we got to do it. We got to take the time to understand this. We can't just copy paste the code blindly and not understand what's going on. You know what I'm saying? So this takes in the rect and self. It returns a bool. Let mute expanded equal rect. We're going to copy that over. Expanded dot x1 minus equal 2, expanded dot x2 plus equal 2, expanded. This pretty much makes sense. We're just like ballooning it out by 2 on each side, and I think I know why we're doing it. Probably has to do with walls. We'll find out. Let mute can build equal true for y in expanded dot y1, 2 expanded dot y2, for x in expanded dot x1, 2 expanded dot x2, if x is greater than self dot map dot width minus 2 can build equal false. If y is greater than self.map.height minus 2 can build equal false. You could do this in like a big old long ugly complex conditional. Yeah, you could, but this is probably a little cleaner looking. You just have to do all the tests every time. If x is less than 1 can build equal false. If y is less than 1, can build equal false. We're not done though. We need to do one more. If can build, let idx equal self.map x dot xy index. It's been a minute since we've needed that. I always do IDS too. I still don't like the IDX. I'd rather type index. I just follow the tutorial. If self.map.tiles idx not equal tile type wall can build equal false. And then we get all the way to the bottom. Can build. So we got a lot of checks here. What did I do? -2. Self.map.height -2. Yeah. Okay. So we expand the rectangle by 2 in each direction. The starting point in the upper left goes up and left by 2. The bottom right corner goes down and right by 2. So we've made an expanded rectangle. We make this can build variable. We assume it to be true, and we'll set it to be false if it's not. So we loop from and including the y1 and y2. We basically do it for every point in the rectangle. And we basically, so you know what I would like to do? Oh no, I see what we're doing. Yeah, we don't want to break out. We could do a continue though. Hold on, am I missing something? If can build is false, it's never going to be true again. Can build is set up here. I don't quite know why we're still looping. Am I missing something? Because we're still going to loop. What if the very first y and x pair, what if this very first conditional fails? Then we should be able to immediately return. Am I wrong? Could you not just make this true and then return false on any of these? Like can build equal false, just return false every time? And then basically if you didn't do that, then you do this check. Am I missing something? I feel like there's a lot of unnecessary looping going on here. Also, why is possible not used? You're lying. Oh, you're not lying because we're not using build yet. It's not used by association. Okay. But yeah, basically if the thing goes outside of the map, if the X or Y values go outside of the map, we're mad. We can't build. Otherwise, if it's already not a wall, meaning we're intersecting another existing room or hallway as well, right? So we get the index, and if it's not a wall, then we say we can't build it. Okay. I'm really bothered by the potential okay, so one note. This isn't going to be that big of a performance hit because we run it one time. It's not going to take very long to run. We run it one time every time we generate the map. No, we don't. We actually run it a lot. But what I mean is we run build one time every time we generate the map. And then we run it 240 times is possible. So we're going to be doing these loops a bit. I don't see any reason that we need to maintain this can build variable, why we can't just immediately return. Because nothing sets it to true except up here. Like if I save this, it's going to tell me that can build may be uninitialized, right? Yeah, see? Well, I wanted it to say it down here, but yeah, we can't do that check because it may be uninitialized. I'm just not seeing any way that makes sense to keep looping. Why don't we just immediately return false on any of these And then if we make it through everything, return true. I'm not seeing it, man. Okay, that's fine. Let's keep going. We're almost, no, we're not almost done. We're getting there though. All right, let's break it down. Let's read the tutorial thing now, because I think I just kind of broke it down, maybe. This is a little more complicated, but it makes sense when you break it down. I didn't realize they said that. So we're going to take a rectangle as a target, representing the room we're looking at. We're going to make a mutable copy of the rectangle called expanded. We expand it out by 2 tiles in each direction to prevent rooms from overlapping. We iterate every x and y coordinate in the rectangle. If x or y are out of the map boundaries, we mark can build as false. This won't work. If we still can build it, we look at the existing map. If it isn't a solid wall, then we've overlapped an existing room and marked that we can't build. We return the result of can build. Now that we've implemented all these, the overall algorithm is more obvious. We start with a single rectangle covering the entire map. We subdivide it, so now our map has 5 rectangles, 1 for each quadrant, 1 for the map as a whole. Okay, let's read the overall, I just kind of was reading. I want to start this over and make it really clear. Here's the overall algorithm. We get a single rectangle over the entire map. Then we subdivide it. So now our map has 5 rectangles, 1 for each quadrant and 1 for the map as a whole. We use a counter to ensure we don't loop forever, and we'll reject a lot of rooms. So while we can still add rooms, we obtain a random rectangle from the rectangles list. Initially, it will be one of the quadrants or the whole map. This list will keep growing as we add subdivisions. Then we generate a random sub-rectangle inside this rectangle. We look to see if it's a possible room. If so, then we apply the room to the map, as in build it. We add it to the rooms list, and then we subdivide the new rectangle into quadrants and add those to our rectangles list. Store a snapshot for the visualizer. That's the last thing we do. So if it's a room, we add it to our rectangles list. The one thing that I'm missing here, the one disconnect that I have, is that we can randomly pick a rectangle of a room that we've already generated. Is that the only time we update the rectangles list? So we'll obtain a this is the disconnect I have. Get a random rectangle from the list. And then we generate a sub-rectangle in that. But the problem is, what I'm missing is, if we find something that's not a wall, then we say we can't build. But if the rectangle comes from the rect list, then we're going to be looking at rooms that we've already built. Am I missing something? This tends to give a nice spread of rooms, and they're guaranteed not to overlap. Very NetHack-like. If we cargo run, you'll be in a room with no exits. You get to watch rooms appear around the map in the visualizer. It's a great start. I don't believe that. You know why? Because we're getting some complaints that none of this is used. We are not calling build. Is it because I never saved mod? Build is never used. Why not? Rects is never read. Did I do, did I make a mistake? Why is that mutable? Get out of here. Where's the generate map thing? Get random builder. We're not. We have build map. You know what it is? mod.rs. We have build map, and it takes and mute self. Should this be build map? Did I make a mistake, or did they make a mistake? No, because oh, you know what it is? We should do something here in build map. It's just going to be self.build, right? There we go. Let's take a look back here real quick. Did I miss that? Build map, we should do something here. And then we add build. Yeah, I never see it being called, but I think that's all we do. So now we should be able to cargo run, and let's take a look at it. We get one shot. Okay. You know what the trick? Yeah, that was it. Okay. Begin new game. And we're here and we can't leave. Which is actually the next thing I noticed the tutorial mentioning. Okay. So you know what I think is happening? I think I'm right. If we break this down one more time, let's look at the build here. The only time we add subrects is at the very beginning, which is the main overall room and the 4 quadrants, or the main overall map and the 4 quadrants. And then we randomly pick one of those. We randomly pick one, and we subdivide it. Well, not subdivide, we just get a random rectangle inside of it. Now, initially, these are not rooms. That's the important thing. So candidate is that, okay, there's the trick. That's the thing. Okay. So this random rect is not the same as the candidate. So the random rect might be, it might be this section here. But the random subrect might be this section here. I'm just gonna draw some more symbols in. Right, so the idea is what we're adding to the subrects thing that we're checking against is this bigger piece here. The actual room is going to be like a smaller piece of that whole rect. What I was concerned about is that every time we check to see, like, because we're getting, okay, so what I'm trying to say is, this rect here that we added to subrects, if we get this same subrect again, actually, hang on. Get random rect. Hold on. Yeah, no, it gets it from self.rect. It gets something from self.rect, just making sure. And then we're adding subrect. Oh my God, it's so weird. So when we add subrects, it actually adds all the 4 quadrants of that. Okay. Yeah. So what I'm trying to say is that it's possible to take this rect here and generate more than one room on it. With the sizes we have, it's not super likely, but it is possible. If what happened is that every rect you put in was the exact room, that would be bad. Because basically the biggest point to note here is that the candidate is the room. And the candidate is a smaller piece than the actual rect that we're using to put in to the subrects, like vector. That's the critical thing. Okay, it makes sense to me. I almost want to like step back and run through the whole thing again, but I might just make it worse. But it's finally clicking with me. And that's critical. I don't care how many times I have to go through it. I'm going to make sure I understand these things before I move on. I'm not going to pretend like I can do binary space partitioning now. I mean, granted, I would have to sit down and think about it to like rewrite from scratch, but it's making sense now. It's definitely clicking. So yeah, let's do another quick run through at a higher level, just looking at the code here and making sure I kind of get what's going on. So we start out with like nothing. We have the whole map though, and we give ourselves 5 different things we can work with. The whole map or each quadrant of the map. So then we pick one of those. It could be the whole map. It could be one of the quadrants. And then from that, we get some smaller rectangle. And that's a potential room. Yeah, that's a potential room. Let me double check one more time. Yeah. Got it. So we get a smaller rect from that. That's a potential room. If we don't encounter any non-walls, if everything is a wall in that potential room, then we can add it. And then what we do is take the rect that we use to generate the smaller one, the room from, we take it and add its subdivisions to our total rects. So what we're basically doing is we're repeatedly dividing different chunks of the map into smaller and smaller pieces. That's the thing that's actually going on here with subrect. If we pick that top left quadrant of the map as our first one, we'll generate a room somewhere in there, but then we'll also add like multiple quadrants. We'll add those 4 smaller quadrants to the map or to our rects as well. And then those become potential things that we can also make rooms from. That's the interesting piece to it. And this is that tree-like structure that we also see. We saw it earlier with the when I pulled up the search with Doom and binary space partitioning, and we saw tree data structures, and I mentioned you can prune off pieces of that. Because everything is generated from these like subdivisions, you actually can. It makes a lot of sense how you could start pruning if you organize it in a tree. You know that when you subdivide something, it all came from this parent. Now, we're not holding them in such a way that I don't think we could easily do that. But when you're making those subdivisions, it's basically like taking a parent node in a tree and then breaking it apart into some leaves, into some children. I think that's how it's being used in Doom, basically. It's the same idea, but we're using it here for, pure map generation. They're using it in Doom to somehow do like rendering and all that. because they can easily say, oh, well, this stems from that, so we can just prune all that off. Okay, I don't know if I'm making sense, but stuff is clicking, stuff is grinding up here. I'm happy with my current understanding now. Again, we're not like tracking where each subrect came from, but again, it all gets tied to like when those, everything can ultimately be linked back to the initial 4 quadrants that we made, except for the slight issue of that whole first room thing. That one is just the whole map, so you can get some oddities there in that it might actually generate something that overlaps those quadrants, which is fine. We probably want to do that for randomness. We could actually, yeah, no, actually, yeah, because we pushed that in here. If we simply made this rectangle but didn't push it into rects, we probably still get a working map, and I want to know, I want to see it. Let's try it real quick. Let first room equal, we'll make that rectangle, and I think everything's happy, so let's run this, and I think we might still get a working map, but it'll be a little bit more, it'll be a little bit less random feeling in that we can't overlap the quadrants. But yeah, we still get a map. It's perfectly fine. So that little experimentation is a way to help confirm that I'm getting how this works. All right, now spend enough time on that. Let's keep going. All right. So now we've implemented. I already read all this. So it gives a nice spread of rooms, and they're guaranteed not to overlap. Very NetHack-like. If you cargo run, you'll get a room with no exits. So we're going to have to add corridors. Now we sort the rooms by left coordinate. You don't have to do this, but it helps make connected rooms line up. By left coordinate, do you mean... Okay, literally just the X. Okay. So let's do it. Where do we do that? Just at the end of build, I guess? Yeah. Self.rooms. Let's make sure I'm not on the browser. Okay, good. Self.rooms.sort by... There's a couple different sort by things. We could do sort by key, which we might be able to get away with. Sort by key is interesting. Sort by A and B. Then we're going to say A.x1.compare to B.x1. What I think would happen here is Clippy might even tell us. Clippy might even tell us that we could do sort by key. I know a lot of things are mad, but don't worry about it. We're not going to worry about it for now. I would definitely be cleaning this up, though. I don't see it. I learned about sort by key recently. That's why I was curious about it. Essentially, what it allowed me to do was self.rooms.sort by key. So we have... Here we do the absolute value. And basically, it's smart enough to compare this absolute value of all the different things in the list. It's kind of smart enough to do that comparison without having to pass 2 things into a closure. Sorts the slice with the key extraction function. So key extraction basically says, get a thing out of here, and that's the thing we're going to compare. And this sorts it with a comparator function. So you're basically, the other one you're telling it what to compare, this you're telling it how to compare, if that makes sense. Okay. So sort by takes a closure, that is an inline function known as a lambda in other languages as a parameter. Okay, I want to be a little technical, and I can't go into the full definitions off the top of my head. A closure and a lambda are not necessarily the exact same thing. There is a similarity. And I'm literally saying this because I was helping someone earlier today. They were working on Python and they were looking at lambdas and they didn't understand the result. And I was like, okay, I can tell you what's happening. And I gave some Rust examples because I'm typing on my phone and I'm like, I don't know Python syntax that well, but I can give a Rust example of something similar and try to use it to explain the concepts. And I said, this is a closure. It's similar, but not exactly the same as a lambda. For the purpose of the demo, it is the same, but there are some differences. And I even Googled it to make sure they were not exactly the same before I said that, because I didn't want to say these are exactly the same and be wrong. So I was reading up on it this morning, and there are some differences. I think a big thing with closure is bringing in outside scope, but I don't know. I don't want to get into that. The whole point was that I just want to be very accurate with what we're saying. So anyway, you could specify a whole other function if you wanted to, or implement traits on rect to make it sortable, but this is easy enough. It sorts by comparing the x1 value of each rectangle. Now we're going to add some corridors. So let's get to doing that. I know I keep taking these asides, but it's interesting stuff. Now we want corridors for I in 0 to self.rooms.len -1. Let room equal self.rooms I. So this is why we're doing a -1, because we're using it to index. Is there a reason we're doing, hang on. Is there a reason we're not doing an iterator? For room in rooms. Oh yeah, we do need to index. I'm stupid because we're going to be going, I haven't even read that far yet, but it just hit me. We need to go from one room to another. So let next room equal, yeah, self dot, there it is. I +1. You can do something. Hold on. Can't you do... Oh, no, you know what you need for it? I think... You could do groups. You could iter in Windows, where basically... this is not... standard Rust. There is an iter tools crate that lets you do it. So if we had a vec of, or an array or whatever, 1, 2, 3, 4, 5, 6, you could iter in groups in windows of different sizes. So if we had a window size of 2, the first one would be 1, 2, then the next one would be 2, 3, then the next one would be 3, 4, and so on. Or if we had a window size of 3, it'd be 1, 2, 3, it'd be 2, 3, 4, and so on. That is in the Rust iter tools crate. And that would actually be one way to do it with iterators without having to worry about indexing and everything. And it'd cut down a little bit on some of the accessing here, but it's not a big deal. Alrighty. I also know that because I've used that recently. I've used related things to that. I've used that crate extensively. All right, let's start y equal room dot y1 plus rng dot roll dice 1 I32 absolute value room dot y1 minus room dot y2 minus 1. Start x, x1, y1, just double checking. x1, x2, y1, y2, yep, minus 1. Okay, good, beautiful. All right, once we get all those, let end x equal next room dot x1 plus rng dot roll dice 1 I32 abs next room dot x1 minus next room dot x2 minus 1. And this is going to be the same for y. Let's replace all the x's with y's. And there we have it. End x and end y. Self.draw corridor. Start x, start y, end x, end y. Self.take snapshot. There's where we get those. Okay. So obviously draw corridor does not exist. Let's have that thing created. And we're going to rename some of these x1. We're basically going to build a rec out of this, aren't we? A rect. Why is my watch vibrating? Good old LinkedIn recruiters and stuff. Let mute x equal x1. Let mute y. Do not want to type my. Some Perl stuff. That was a typo. It was supposed to be mute, but mute y, and I made a mistake. But also Perl makes me sad. If x is less than x2, x plus equal 1. Else if x is greater than x2, x minus equal 1. Else if y is less than y2, y plus equal 1. Else if y is greater than y2, y minus equal 1. It's going to be an interesting loop there. Let idx equals self.map .xy index x and y self.map .tiles idx equal tile type floor. Oh, how did I get a C there? There we are. And this needs to be mutable. Okay. Missed that because I let it auto-generate and it didn't know yet. Alrighty. But it makes sense, of course. We're drawing, we're modifying. That makes sense. I just didn't pay attention. So there we go. What are we doing? Well, we basically have... This is not a rectangle. I misspoke earlier. It's not a rec... I just, as I was seeing the way these were named, I was thinking of a rectangle. No. These are 2 points. These are like... are they center points? Start X and start Y. No, we're picking random points within those areas. So they're not exactly center points, but we're picking a spot in the room. In both rooms, basically, we're picking a spot. And those are the points where we're going to draw from and to. So we go from x1 to x2. So if x is less than... So we're going to go horizontal first. If x is less than x2 or greater than x2, then we move accordingly. We move left or right. And eventually they're going to be equal, so we're going to fall into this third case here where it's the same thing. We do y. So we're going to do whichever y thing is appropriate, y being less or greater. We're going to add or subtract as necessary until the y values are equal. So basically, we have 2 different points here. We move x until the x values are equal. Then we move y until the y values are equal. And we've built that corridor. So every time we run through this loop, we get that index itself from the map and we set it to floor. So it's no longer a wall. Let me double check one thing. Okay, no, we're good. All right. As well, if it's possible, apply room to map is what actually carves it. Okay, yeah, that's right. I had to make sure. I was like, where do we do the floor stuff that's already in one of the common functions? All right. Good Lord. It's a lot, but it's good stuff. So let me read back. I didn't read what's going on this first bit where we're adding corridors. So what we're doing is, I feel like I kind of already explained it anyway, but it iterates the rooms list, ignoring the last one. It fetches the current room and the next one in the list and calculates a random location. Start X, start Y, and end X, end Y, within each room. It then calls the mysterious draw corridor function with these coordinates, and draw corridor adds a line from the start to the end. Using only north-south or east-west, it can give 90-degree bends. It won't give you a staggered, hard-to-navigate perfect line like Bresenham would. What? Is that another algorithm that I don't know? Is this something? Okay, line algorithm. I was going to say, am I allowed to look at this? Okay, yeah, I was going to say, is it a jagged line like that? Yeah, we got this jagged line here. Because how did he describe it? A staggered, hard to navigate, yeah, perfect line as in a diagonal, right? And then we take a snapshot, which, yeah, that's self-explanatory. So draw corridor is quite simple. It takes a start and end point, creates a mutable x and y variable equal to the starting location, and keeps going until x and y match the end of the line. For each iteration, if x is less than the ending x, it goes left. If it's greater, it goes right. And same for y, but with up and down. This gives straight corridors with a single corner. And then, don't forget stairs. I nearly did. I mean, to be fair, I did right now, but I'm the one following the tutorial. Finally, we need to wrap up and create the exit. So don't forget the stairs. I'm intentionally not going to scroll down. I don't want to spoil it with their animation. I want to do this ourselves. We'll run it here in just a moment after I add the stairs. I hope this algorithm made sense. It's definitely clicked with me, but it took some time. So don't forget the stairs. Let stairs equals self.rooms, self.rooms.len minus 1 dot center. So this is what we've done before. We get the center of the last room. Stairs idx equals self.map.xy idx stairs.0 not owned stairs.1 self.map.tiles stairs idx equal tile type downstairs. Boom. When we place the exit in the last room, guaranteeing that the poor player has a ways to walk. A little bit. Depends on how the rooms link up, right? Am I missing something? I got to think about how this works. No, we might still cut between different rooms. They're being facetious in the tutorial, I know. Okay, so we get all the rooms, and then let's watch this, how it... Ah, that's so cool. Oh, no, that was interesting. Did you catch that? All right, let's play this thing for a minute. Let's try to get a magic map scroll on one of these. Oh, actually, we didn't know what the first and last room... I mean, we did if we paid enough attention, but... So this already feels different to navigate, which is kind of cool. All right, we found it. Which means I want to go back here. We got the magic mapping. I want to save it for maybe the next map. Actually, no, I want to do it here because we saw this map generate. We already saw this one generate, so let's magic map it and take a full look at it here. So this was the starting room, And we saw there's a lot of interesting stuff here where we have like this tunnel goes down and over something. This is kind of a cool look. I like it. You know what we don't know? We don't know about items. So there could be items like all over, yeah. Magic missile. I'd like another magic mapping for the next floor. Whoa! Alright, we got fireball. Nah. We got a dagger though. Magic missile. Get bopped, dude. Do you have a shield? No, not really. Eat. I'll waste and lose my well-fed bonus. Alright, let's get out of here then. I was hoping to see another floor, another level of this. We could look down here. Okay, no, nothing. Yeah, this is actually a lot harder to navigate. You'll notice, even though there is some randomness in how things are going to be generated, it seems like it's a lot harder to navigate, which is not necessarily a good or bad thing. Interesting little deal at the top there, a little nub. So yeah, I think it'll be cool to see a couple maps here and see how things change. Ah, that's what I want. Magic mapping. Yeah, very similar style. I mean, as should be expected, it's an algorithm. The algorithm should produce a certain kind of result that we expect. So very similar style here, which is pretty cool. I'm a big fan of that. And you know, they said guaranteeing that the player has to walk a long way. There's actually something to that. Depending on how they generate, because we go in order of rooms, unless we get some... Oh, what a dummy. You stepped on the trap. Because they go in order of the rooms, in order that the room's generated, we get some nice guarantee, or not guarantees, but we get some nice general behavior in the algorithm that says unless we get some lucky overlaps. Where's that tower shield? Oh. Unless we get some lucky overlaps, we kind of do have to walk a long way. Now, it is possible we get some overlaps, like we saw some, well, we saw one there, but it didn't really do much for us. So all that way led us to a dead end. Now, that kind of thing sometimes happened on our old simple map, but not as often, right? This seems to be more the norm on our current map system here. Yeah, they can't hurt me anymore because I got the tower shield. Now it's all about food. Yeah, look how much we have to walk through here. We're still not at the end. So again, unless we get some lucky overlaps... Whoa. I can't press anything after Z, but it is giving me more options. We never really tested that. We are allowed to pick up more than we can use. Very interesting. Do I have another magic map? I don't. So I'm not going to play anymore, I don't think. But it's cool. We've read through a few levels here, and we've seen we're getting some pretty similar results for each level of the map here. Now that one's really interesting. Does that link up to something else? We got a lucky little corner there. That's different. We wouldn't have got that before. I don't think we've ever seen one of those. We've ran a lot of maps on this thing. Here's what I wanted. Let's eat some rations. Let's have a health potion. And another one. And a longsword. We can fight things faster. Fight fire with fire. Yeah, we really do have to walk a long way. It converges in. Like, it's not going to be guaranteed 100% of the time, but it's pretty good about it. I like it. Alrighty. Let's go back over here. We're like done now, right? Yeah, and they say guaranteeing that the poor player has a ways to walk. So that was the starting room. Oh, right. No, the trick was not in the order. Right, I'm dumb. We just did it and I forgot. We sorted the rooms. That's why when we watch the corridors, they go from left to right. So there's still the potential for some overlaps that make things a little bit easier on navigating, but for the most part, it is from left to right. That's what gets us some really interesting results. Okay. We're going to randomize the dungeon per level. Rather than always using the BSP sewer algorithm, we would like to sometimes use one or the other. In Map Builder's mod, we replace the build function. Let's see. Let mute RNG equal RLTK random number generator new. Let builder equal RNG.roll dice. A 1 and a 2. We're going to match builder. And this is going to be 1 and 2. Need my commas. Okay, yeah, we can do 2. I was about to say. It knows it's an int. So even though we know it could only be a 1 or a 2, it doesn't know that. Right now when we play, it's a coin toss. The spawn functions for the types are the same, so we're not going to worry about map builder state until the next chapter. Okay. Cool. So you've refactored your map building into a whole new module and built a simple binary space partitioning based map. The game randomly picks a map type and you have more variety. The next chapter will further refactor map generation and introduce another technique. So this one's shorter. Let's take a look at the bar, the scroll bar here. The little line here is about halfway through the scroll bar. And there's a noticeable change, but not a whole lot. Do I want to do it? We're about 2.5 hours in. Again, this will be shorter. I don't want to spoil it. In the last chapter, we used binary space partition to build a dungeon with rooms. The thing is, this is not like, this is one of those things where I don't want to rush, but I really want to see the next thing. This is not me trying to like cram in as many of these as possible into as few streams as possible to just get through it. This is me wanting to do it for my own sake. So we use BSP. BSP is flexible and can help you with a lot of problems. In this example, we're going to modify BSP to design an interior dungeon completely inside a rectangular structure, for example, a castle, and with no wasted space other than interior walls. Oh, I think I get the idea. So we're going to say, here's a big rectangle or whatever. Here's your confines. Divide this up into different rooms or whatever. So the code for this chapter is converted from one night in the dungeon's prison levels. So scaffolding. I don't think literally scaffolding. I think code scaffolding. We'll start by making new file, mapbuilders bspinterior.rs, and putting it in the same initial boilerplate that we used in the previous chapter. All right, give me a moment. Oops, hold on. Just a moment, sorry. So I was double checking something. All right, I got water? Yeah, I do. Okay, map builders bspinterior.rs. Let me get that thing thrown in. We're going to use the same initial boilerplate from the previous chapter. So if that's the case, I can probably copy most of this, if not all. We're going to go to BSP Dungeon and we'll grab this stuff here. This is going to be BSP Interior Builder. Map, starting position, depth, rooms, history, rects. Good. We're going to do an impl for that. Not what I want. This is just to make the new. Wait, that's not it. Where's the new at? Oh, it's right here. BSP interior. So impl BSP interior builder. Bop. And we swap that with that and that. And we need to go back here into mod and use it. Mod BSP interior. Okay. This is going to be a lot shorter than I realized because there's so much boilerplate here. We're going to say impl map builder for BSP interior builder. And we're going to bop that in, and here's what we're going to do. We're going to take BSP dungeon. So many of these are going to be the same. So let's copy this all. It's probably going to be like almost identical. We're going to pop BSP dungeon back in here. Alrighty. So let's just double check. We don't have a build yet. Yeah, they say we should do something here as the as a comment for that. So we're getting complaints, but that's fine. Spawning, I think, is the same so far. Snapshot's going to be the same. Self.history.clone on history app. I think we're good. I mean, just to be safe, I could do this too. I could copy theirs and put it in here. We don't have world. Why not? Now it breaks things. What do we do here? Spawn entities. Oh, specs world. That's why that was there. Get starting position. What's the difference between that? And mute self returns a position. Yeah, it doesn't need to be mutable. We'll get rid of the mutability over here too. I don't know why. I think, well, some of these I've questioned as we're doing the tutorial. I was like, why is that mutable? And it feels like they silently changed on me. I mean, maybe I made a mistake somewhere, but it feels like some of these silently changed on me. Build map should be mutable. Yeah. ESP dungeon. Build map is mutable. I did the wrong one, didn't I? Yeah, get map. Yeah, because those don't make any changes. These were things I pointed out. Like I said, I feel like maybe I just made a mistake. But every time I'm typing these, I'm like, this doesn't change anything. Why? I've made that comment a couple times tonight. Why is this taking a mutable reference? Okay. Took longer than it really needed to. I could have just copied the whole thing, but I didn't want to be that lazy. We'll also change our random builder to once again always randomly pick the new algorithm. Yeah. So it sucks because we literally just did this a few minutes ago. And now it's like, yoink. We're going to just box up a BSP interior builder. Oh, okay. Well, just pull it in. However you want to do it. Just get it in the file. Oops, I'm sorry. We could do use BSP interior star. I've done that in the past. This is fine either way. It doesn't matter. Okay. Subdividing into rooms. We're not going to achieve a perfect subdivision due to rounding issues, but we can get pretty close. Yeah, so one of the issues that we're going to run into is that we're using tiles, and when you start dividing, you're going to have some issues there because you can't always do things perfectly. But certainly, it's going to be certainly good enough for a game. So we put together a build function quite similar to the one from the previous chapter. Where do we want to build? I think in here, right? Let's double check. Yeah, it's in there. Right after the new. Yeah. All right. Pub effin. No, just regular effin. Effin build. And mute self. It's got to be mutable. You know it. Let mute RNG equal random number generator. Ooh. Okay. Off to a good start. Self.rect.clear. Self.rect.push. Rect. New 1 self.map.width -2. Self.map.height -2. Let's see, we're using a different number here. We used 5 on the other one for whatever reason. Now we're doing -2 here, and I would have been more happy, but we did the other one. We started at 2 and 2 instead of 1 1. There's some arbitrariness there that just really bothered me. All right, self.add subrect first room and mute RNG. Divide the first room. All right, that's probably going to get mad because we haven't defined that here. Let rooms equal self.rect.clone. For r in rooms.iter. Let room equal *r. So we're dereferencing that, saving a local copy of it. It gets cloned, I think. We already have a clone of it. No, okay. Room.x2 minus equal 1. Room.x or y2 minus equal 1. Hey, it's commented out in the code. So I'm gonna, in the tutorial, I'm gonna comment it out here. We're just gonna roll with it, okay? Self.rooms.push room for y in room.y1 through room.y2 for x in room.x1, room.x2, let idx equals self.map.xy index with x and y. If index is greater than 0 and index is less than self.map.width, self.map.height minus 1 as use size, self.map tiles idx, will tile type floor. Cool. We go down, down, down to the burning lake of fire. Take snapshot. Go down another. Let's start equals self rooms 0.center. I feel like we left a lot of stuff out here, so I'm going to be curious how this works. So what is x? It is start.0, yes. And y is start.1. We go nice and quick through all this. We don't have a subrect, but I feel like we skipped through some of this stuff. So do we need, are we defining, yeah, we're defining subrects here, so I'm not going to do it yet. I was like, is this going to be the same as the other one? I'll copy it if so, but no, we're going to be defining something in a minute. So what do? We clear the rects, we push in a new one that's basically the whole map, and we call that the first room. Then we subdivide it, we add the subdivisions of it, and then we clone those as rooms. Very interested in that. So self.rect is all the rooms, but I'm curious because we have the whole map as a room and then we have the subdivisions as rooms. For each room, we push it into the rooms vec. And then for the X and Y values, from, okay, no, we're just converting the room into floor. Huh. We're just changing it from walls to floors. We're not really doing much. Okay, I'll take their word for it for now. So the tutorial says, look at what this does. We create a new random number generator. We clear the recs list and add a rectangle covering the whole map. We call a magical function add subrects on the rectangle. More on that in a minute. We copy the rooms list to avoid boring issues. Borrowing, typo there. For each room, we add it to the rooms list and carve it out of the map. We also take a snapshot. So the one thing I was questioning, and when I was just mentioning how this is different. I believe this is different. Maybe it's not actually. First room and mute RNG. It is different, see? Well, no, you can't see it because I'm covering it up. In the BSP dungeons, when we do add subrecs, it's only taken first room. So there is something different going on already. Okay. That's why it stood out to me. So, take a snapshot. Yep, add it to the rooms list, carve it out, take a snapshot, boom. Start the player in the first room, simple enough. The add subrecs function in this case does all the hard work. I thought it was going to. Because I'm like, there's something missing. This is too simple. So we need add subrects. We're not going to spoil what it does down there. We're going to generate a easy one here. Self, it's going to be and mute self, which I think that one's self-explanatory. Rect and RNG. I say it's self-explanatory because we're going to be modifying stuff related. At the very minimum, if we're adding stuff into the self.rects or something, self.rooms, anything like that. Well, we're not adding to rooms, but self.rects. We're going to be putting stuff in self.rects because we're going to then be cloning from it. We know we're modifying that, so it needs to be unmute self. Remove the last rect from the list. And I knew it. If not self.rects.is empty, self.rect.remove self.rect len -1. I knew it. Okay, there's our trick. This is actually something I was anticipating. I didn't vocalize it entirely, but I think I mentioned it, where if the whole map is a room, it's going to get carved out. That was concerning me, and I thought, one of my earliest thoughts was that we must remove it, and it turns out we do. Okay. Calculate boundaries. Let width equal rect.x2 minus rect.x1. Let height equal rect.y2 minus rect.y1. Let half width equal width divided by 2. You don't have to put spaces. I like it. So you see me backspacing when I miss the space there. It's just because I like it. Let half height equal height divided by 2. Let split equal RNG.roll dice. And it's going to be 1 and a 4. 1d4. If split... Okay, we're literally... Is there a reason we did 1 to 4? Say if split is less equal 2. Oh. Wait. No, because that produces 1, 2, 3, or 4. It's like a dice. Why wouldn't we just say a 1d2 and then say 1 or 2? Am I missing something? Whatever. I'm too critical sometimes, but I just wonder why we picked a 1d4. And then there's only 2 possibilities here, an if or an else. Why not roll a 1d2? Why not, like, just... Can we get a Boolean even? Returns a random value of whatever type. Rand, bool. You could just do that. Whatever. Whatever. Okay. Horizontal split. Let h1 equal rect new rect dot x1 rect dot y1 half width -1 height. Okay, so we're splitting horizontal or vertical. So we have a rectangle. We're just gonna snip right down the middle. Okay. Self.rects.push h1. So that's our new rectangle. If half width greater than min room size, which we don't have yet, self.add subrects, ooh, recursive, h1 RNG. Let h2 equal rect. Now, how much you want to bet? This is going to be the other half of the room. Rect new, rect dot, it's going to be x1, yeah, plus half width. Rect.y1 half width height. Actually, though, I was thinking if it's horizontal, shouldn't y be changing? Horizontal split, the x would be the same, but where you start it would move up and down, wouldn't it? I don't know. I'll take their word for it. Self.rects.push h2 if half width greater than min room size self.add subrects h2 RNG. We need a base case, right? At some point. Oh, the base case is our min and max, or our min room size. Yeah, okay. So we need an else now. At some point, we're not going to satisfy that conditional, and we're not going to recursively call anymore. So we're going to keep making rooms until they get smaller. They're going to get smaller and smaller. Vertical split. And these are going to be called V1 and V2. And I got to really read this carefully. So it's going to be X1, Y1 width. Yeah, when they're saying horizontal and vertical split, they mean something different than I do. To me, a horizontal split means running something horizontally through it. But what we can, but what we can see is when they say vertical split, they're reducing the height. They're reducing the height. To me, that's a horizontal split. A horizontal split makes it shorter because you're cutting it in half with a horizontal line. Okay. So rect x1, y1 width half height minus 1. Self rex push v1, and then this is going to be half height. And then we add v1 with RNG, and it keeps doing this. Okay, so now v2 rect x1, none of this stuff. So this is going to be rect y1 plus half height. And then this is going to be width and then half height. And then this is also going to be half height. Is greater than min room size. Yeah. So basically, if the half height ever gets below the minimum room size, we stop. But this is an interesting recursive function where we're going to take the whole map and then we're going to split it. And then for both pieces of that split, we're going to split those potentially in different ways. We're going to get smaller and smaller. Okay. This is going to be cool. So, can I draw a little picture of it? That's going to be hard. Basically, do I even want to do this? No. It's going to be hard to show. Basically, imagine you take your quadrants, right? Or no, not even your quadrants. Take the full box, and then again, we split it. Say we split it vertically. Now we have two pieces. We have two chunks. We can split both of those vertically or horizontally. And then those give us chunks that we can split. And we can keep getting smaller and smaller splits until we get to this min room size. So this is going to be a cool interior. Okay. So they say, let's take a look at what this function does. If the rect list isn't empty, we remove the last item from the list. This has the effect of removing the last rectangle we added. So when we start, we're removing the rectangle covering the whole map. Later on, we're removing a rectangle because we're dividing it. This way we won't have overlaps. Okay, I did miss that as well, but yeah, that makes sense too. We only want like the smallest ones that we build. Okay, so then we calculate the width and height of the rectangle as well as half the width and height. We roll a dice, a 50% chance of a horizontal or vertical split. Again, I don't see why you do a 1d4 and check on 2 rather than a 1d2. Okay, whatever. This seems very strange to me. If we're splitting horizontally, we make H1 a new rectangle. It covers the left half. We add it to rects. And then if half width is bigger than the min room size, we recursively call add subrects again with that left H1 rectangle as the target. And then we make H2 a new rectangle covering the right side of the parent rectangle. And we add H2 to the recs list. And once again, if half width is bigger than the min room size, we recursively call add subrects again with H2 as the target rectangle. If we're splitting vertically, it's the same, but with top and bottom rectangles instead. Conceptually, this starts with the rectangle, a horizontal split. See, again, I don't agree. I guess I see why they call it a horizontal split, but to me, a horizontal split would be a horizontal line. They're using reverse terminology from the way my brain processes it. But yeah, so we split it this way, and then the next split might be the other way, and we keep doing it. And we get smaller and smaller rooms until we reach a point where we're good. Now, where is this constant, this min room size? I don't know what size they went with. I'm gonna hide the browser. Min room size. 1, 2, 3, 4, 5, 6. Nope. Every instance is in there. It was never explicitly defined. I skipped past it, so I didn't get to see the spoiler either of what it's going to look like. I already know what it's going to look like because I can not literally envision it because I have aphantasia, but I understand the algorithm. My brain knows what I should expect. I'm going to go to the map builders and I'm going to go to BSP interior and I'm going to get that min room size of 8. We're going to paste that in here. Just grabbed it from the finished source for the lesson. We're actually almost done though. I didn't really have to scroll down very far, so that's not bad at all. We're in BSP interior. It's never used because we're not calling build, which we did last time. And I can run it now. We get to watch this one time. It's going to be quick. Remember, we're not linking up the rooms with like doorways or anything. We don't have stairs or anything yet. That's probably going to be the main thing we do after this, is finalizing the, making it playable basically. There we are. Cool. All right. We got a quick glimpse of it, and we can like walk around the room, but that's about it. And then if I wait long enough, we'll starve to death. Okay, so I'm not gonna actually do that. We can see here their example. We'll see rooms appearing. Now we're gonna add doorways. It's all well and good to have rooms, but without doors connecting them, it's not going to be a very fun experience. Fortunately, the exact same code from the previous chapter will work here also. Well, guess what that means I'm going to do? I'm going to copy pasta. That's my favorite kind of pasta. Now we want corridors. He said exact. I'm going to assume that means exact. We're going to put it, I guess after the starting position? Doesn't matter. Although we don't have draw corridor yet. This in turn calls the unchanged draw corridor function. I can already see that. So guess what I'm going to do? I'm going to make draw corridor just the same. It says, literally the tutorial says unchanged. Don't forget the stairs. I nearly did again. So I will do a quick compare. I and 0 dot dot self rooms len -1. Well, okay. Let room equal self dot rooms I. Let next room. I mean, it's looking. It says it's the same. I'm trusting it's the same. Draw corridor. And it looks pretty much the same. Just eyeballing it, it looks the same. Don't forget the stairs. I nearly did again. Finally, we'll wrap up, and I'm going to bet that's about the same as well. Where are the stairs at? Let's just copy the stairs, then I'll compare. It's faster to do that than it is to type it. Now, we're having some interesting stuff go on here, right? We're getting a lot of repetition now. I wouldn't be surprised if we're able to refactor some of this. It might be a little odd, but we might be able to refactor some of it at some point. So it's stairs, we get the last room, stairs IDX, yeah, blah, 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 it's the same, right? We place the exit in the last room, guaranteeing the poor player has a ways to walk. It's literally the same. I think they copy pasted that bit. All right, let's run it. If you cargo run, you'll see something like this. Let's go. Okay, I like where we're going for now. There we are. Oh, that's a cool map to navigate, though. I'm kind of thinking about, like, that is a cool map, isn't it? Now, we had a problem here with generating something in the wall. I find that one interesting. Wonder if we're going to cover that as a bug somewhere along the way. I'd like to figure out why it happened. I don't think we've ever seen that happen before. Yeah, this map is sick. Wait, he was in the... Okay. We've had that happen twice already. 3 times. Something is a little goofy here. 4 times. 5. Okay. It's cool, but there is clearly an issue. But before I jump the gun and say I made a mistake, we're going to test their code. If we cargo run, we see something like this. Oh, we're going to restore randomness again, too. We'll do that in a minute. There's nothing special about that. It's just adding, and it's changing the dice roller to 1/3. Like, that's fine, right? We don't need to go over that. Wrap up. This type of dungeon can represent an interior, maybe of a spaceship, a castle, or even a home. You can tweak dimensions, door placement, and bias the splitting as you see fit, but you'll get a map that makes most of the available space usable by the game. It's probably worth sparing with these levels, being sparing with these levels, or incorporating them into other levels. They can lack variety even though they are random. Yeah, so when we say incorporating them into other levels, I could see it where you could give it a bounding box and only do that for part of an area rather than the entire screen. I think we're going to end up doing stuff like that too. We're going to be making houses and stuff later, so I know that's going to happen. With better corridors, room builders, all kinds of stuff. Let's run this game here in the browser. See what happens. Let's run it again. Let's run it again. Let's run it again. And again. There we go. Okay. He has the randomness on, so we got to keep running it until we get one of these. I want to see if we get things spawning in the walls here. And if we do, I'm going to let mine continue doing that. Because why not? Okay, what am I at? 133. Let's go back to 133 when I'm done with this as my zoom level. Also, the outer border is not really drawing the same. Okay, yep. He's got stuff spawning in the walls here. I'm going to ignore that for now. Not that it's not something I would want to fix, but it's not something that I made a mistake on. That's the critical thing here. I will say, I do really like this tutorial, but we've been finding more and more of these little bugs recently. And I know they've gone on to actually release something else. They've released a book, which I think they actually got paid to do. If I remember reading correctly one time when I was looking at something about this tutorial, someone was complaining about CPU percentage was like really high when running this. They complained about it, And I believe somebody mentioned that this, it's like, stop complaining, it's a great tutorial. And it's like, it's even got him a book deal. I remember reading that. I don't know. Point is, I think that book is like a physical book, and it's probably had extra review and everything, like an actual editor goes through the book or something, I would imagine. So I'm sure that doesn't have some of these bugs and all that. And this is a bit older, so it's likely going to be a little more prone to those errors and stuff, as it's probably not been updated in a bit. So that's fine. I'm not saying that they're like, I know that they have a lot of game development experience. It's just little things slip by, little things kind of slip by at times, and it's okay, right? We won't try to judge too harshly. But what I like to confirm is, did I make the mistake or did he make the mistake? Because if I made the mistake, I should go figure out what the problem is. If he made the mistake, it's, maybe not, right? Because we're following the tutorial. I am genuinely curious why things are spawning in the walls, though. But we've been going for a little over 3 hours, so I don't want to spend any more time on it right now. I'm tired. I've been up since 5 o'clock. Local time is 20:02. What's going on, Jaeger? With the nice wave emojis. Yeah, because I am wrapping up. Well, this is good. We got some good progress today. I'm going to peek like I like to do at the Cellular Automata map. Cellular Automata, let me give a quick primer on that, because Cellular Automata is really cool. If you're still listening, Jaeger, this might be of interest to you. Cellular Automata is this essentially a type of system where you define, generally speaking, some basic... No, I didn't think so. Maybe I'm wrong. Usually you would define some simple rules, and the cellular automata would obey those rules, and you get some really interesting behavior from it. One of the most basic examples is Conway's Game of Life. It's imagine you have like a grid, and each grid is either alive or dead, and there's a few set of simple rules that determines whether or not that cell, you call the tile in the grid a cell. That's typically what you refer to it as, cellular automata. The state of its neighbors determines whether it's alive or dead in the next round, if you will. So what I mean by that is, if there's too many cells that are living, then that cell doesn't live the next round. And it's kind of simulating maybe like overpopulation or something, right? If there's not enough, then it can't reproduce, so it dies out. If there's just the right amount of cells around it, then it can live on to the next round. And you get some really cool behavior, but it's a really, really simple set of rules. The rules are so simple that, someone who's been learning how to program for 2 weeks could do that, could probably make the rules, right? They're not difficult at all, but it's produced some extremely interesting visualizations and stuff that people have made. Another example, and this is why I said Jaeger might find this interesting, another example of cellular automata is like these falling sand games and stuff, and Noita. Noita is basically like a falling sand game with normal gameplay on top of it. So the way it works in Noita is you would have something like water, and water has some very simple rules. If you take water, basically you take a pixel of water in a falling sand game. It's a type of it's a cellular automata system, so it has basic rules that it follows, and it'll say something like, try to go straight down. If that path is blocked, then try to go down and to the left, or try to go down and to the right if that path is blocked. So what you do is you get this thing where it like fans out, or not fans out, but like this stream of water coming down will end up like running off to the sides like that, and you get this like visualization of water flowing, and that's like how it looks in Noita. But it's a very simple rule. So that's using something called cellular automata. So we're going to use cellular automata to make maps, which I think is going to be interesting, and we'll see how this ends up looking here. But I'm really interested in this, just knowing about cellular automata, having done Conway's Game of Life, having done some implementations of this over the years, having having looked a lot into like Noita and stuff. Like, I'm really interested in seeing how we apply this to make maps. So what we have here is the example of the Game of Life. Like I was talking, we could see the grid, and then these tiles are the black tiles here are the ones that are alive. And then, like, I think these are some of the patterns. Like, there's all these interesting patterns you can make that like live forever. Or I think this is a glider, and if you actually like run this from frame to frame, it actually just like moves. There's some really interesting stuff people have done with this thing. There are actually like entire papers written on it. But it's cool stuff. Like, you could, it's actually, you can make gates and stuff with it, which basically means it's Turing complete. You could program in it if you wanted. Would you ever do that? No. But it's cool stuff. So that was a little primer on cellular automata in general. I mean, we can peek through this a little bit, and yeah, we're going to get some interesting stuff going on here. Very simple algorithm, but produces quite beautiful results. And here it is. So we have some basic rules. If there are more than 4 or 0 neighboring walls, then the tile becomes a wall. Otherwise, it becomes a floor. This is the same idea of what I was just trying to describe with the other stuff, right? So with Noita, you have the sand or the water or whatever falling, and it has some basic rules, and that's actually what allows it to like pile up like that. Because if there's nowhere else for it to keep spreading out, it just kind of has to pile up and stay in one place. Particularly with the sand, the water will still be able to like level out because of the way its rules are defined. But like each cell type in the game, whether it be water, sand, dirt, whatever, has its own set of rules, and it's just an interaction of those rules which make that game so chaotic. All right, so it's cool stuff. So we're gonna be making like caves and stuff with it next time. I'm really excited to check this one out. And then after that'll be the Drunkard's Walk. I don't know if we're gonna do both of those next time or not, because they're both a little bit lengthier, but there is a lot of boilerplate here that's very samey. So this stuff goes pretty quickly. True. That is true. All right. So enough of me rambling. I'm tired. I've been up since, like I said, about 5 o'clock, a little bit after, but about 5. It is now 20:09. I want to relax. So it's been a good session today, though. I didn't expect to get through 3 sections, but I'm glad I did, because it also kind of works getting both the binary space partitioning algorithms out of the way. And I've been really excited about that one, since I know it's used in Doom and all that for the Doom rendering. So it's cool to see an example of it. One more quick aside: binary space partition. Just want to see if there's like a Wikipedia algorithm. A lot of times there's pseudocode algorithms here. Yeah, here we go. So we could see some different algorithms, basically, of how we can implement, how we can use this thing. How to traverse. So we're treating it as a tree as well. So this is where I was talking about in Doom, you can prune the tree, and that's how they decide what to render, what not to render. Always good stuff. Yeah, we're literally using it. We then render the polygons of A. We're literally talking about it in that context of rendering. Cool. All right. Enough of that. So thank you, anyone who showed up. I really appreciate it. If you like these streams, this coding stuff, hit that follow button. Or if you want to see some of the gameplay, hit that follow button. And 2, because you get both of them here. I do my coding streams on Monday, Wednesday. Every other day is gameplay. 2 streams on Saturday, 2 streams on Sunday. I'm not going to go over the full game schedule here, but I play all kinds of games. Good stuff. If you're watching this in the future on YouTube, congrats on being in the future. I would appreciate if you could do all the fun YouTube stuff like licking that like button and kicking that subscribe button and notification bell. Leave a comment. I would appreciate that. I do read my comments. I will hopefully respond as well. I'll try at least. That's about it. I don't feel like there's any. I don't think there's anything else I want to cover. So until next time. I do feel like I'm missing something though. It's weird. I went so fast. Oh well, until next time, have a good day, have a good night, whatever it is, wherever you're at, and take it easy. Oh, Jaeger got me. I realized what I was forgetting. Don't forget to drink more Ovaltine.